couldn't understand all the words. I think there's still some problems on Marcel's side, or some problems with my in output hardware here. Anyway, I assume I start my talk, and I will leave some time at the end for questions. So today I'm going to present this project of mine. I actually presented already a very early version of it in, I think it was 10 or 2018, if I am not incorrect. So linear stands for live generated interface and notation environment in augmented reality. Sorry, let me just. Okay. So the first thing I want to do, I always do this just because I don't know how many people are still familiar with augmented reality. I want to say what is augmented reality. And I want to use, I think, the most well-known and used adopted definition of augmented reality in the literature, not only for music, which is the Azuma definition. We have three main characteristics. So it needs to combine real and virtual objects in a real environment. So that's visually combined. It has to be interactive. So virtual objects need to react to input devices of some kind, and registers or aligns real and virtual objects with each other. It means virtual objects will react to the real environment in some way. Like, for example, a virtual ball will bounce on the real wall. And just for a simple, simply showing, this is one of my old projects. Anyway, you can see there's these buttons, virtual buttons around the physical object. And my hand can actually touch and activate one of these virtual buttons. So this is like a very rough representation of what augmented reality is. And augmented reality is bound to devices. So it's nothing that happens if you don't have actually something to represent these virtual objects. So it's typically, it's typically, it typically needs either or head-mounted displays. So it's VR headsets that have front-facing cameras that enable to see the real world on the screen in front of the eyes, and then see-through devices like HoloLens, the one that David presented earlier. Basically, you can see the real environment because the glasses are transparent, but they are also able to project holograms on the retina, and then projectors also. But the projectors will typically project on flat screens, so the immersivity of it is less and less. Just to say, so what happened in the literature in music in the past years, I think there's two main branches in which we can divide it. One is education, which is also the most researched one. And then there's what we are going to talk about today mostly, which is research on musical notation and virtual interfaces. And in that field, I found four main distinctions. We can find four main distinctions. One is immersive scores, and I think David is works very much on that. For example, embodied interactive notation, which has been a part of what I have been developing in other researches. Basically, you can represent a gesture through the means of virtual objects. You can leave traces of gestures in the three-dimensional space, and then you can have notation of gestures. Augmented instruments in augmented reality, so that's not. And then also in recent years, aids for rehearsal, like you have a PDF, but this PDF is in augmented reality and you can move it around, you can share with other performers, etc. I don't want to talk much longer about this, so I won't show this V clip, and we can just go on with presenting AR in music education. Is been, let's say, mostly addressed to beginners. And for example, here you can see an example of piano roll. I'm presenting this because this is one of the most adopted applications in augmented reality for music. The piano roll for piano performance. I think I found between 18 and 20 papers in the past 5 years. So it's really a hot topic for musical research. Okay, so let's talk about this, let's say, environment that I called linear. And I want to talk about why I decided to do something like that and why I keep working on it. A flow chart, so how does all the signal routing, etc. works. And then I have to say, so this system actually is not just one application, it's several applications distributed across different devices. So there is one application an Ableton Live project that processes live performance sounds and is regulated by a laptop performer. All of these applications go together to create like a musical performance. And then I want to talk briefly about scores, performance notes, a performance outline. And if I have time, I will also talk a bit about an evaluation I did of this project. So why? Because I think augmented reality has unprecedented capabilities of representation and interaction in space. What I was talking about earlier, for example, representation of gesture, so gestural notation, but also it can provide three-dimensional interactive graphic notation. So I said, okay, I see really a lot of possibilities in these new affordances of this new, not only technology, but I think it's really a new medium. So I want to like explore, and it's really an explorative approach, what can be new, unexperimented, new, unproposed solutions that use, for example, gestural notation and 3D graphic interactive notation all together to create something that can have potential of further development or can be useful and let's say artistically valuable and viable for musical performance. So this is how the whole system. Here you have also some legend. So sends OSC data to the computer. And this iPhone will actually generate in real time virtual objects. And it is mirrored through a streaming box and a projector to a screen that shows a real-time score. Performers read from this real-time score and they are processed live through processing on the computer. At the same time, the headset sends and receive visual data and actually video data to and from the laptop, and then the laptop sends also the feed of the headset to a projector. Last thing, let's say the iPhone performer, which creates virtual bodies in real time, refers to an outline, a score, which regulates how he and what kind of virtual bodies he should produce at a certain time in order to deliver a real-time score, a real-time interactive graphic score that is used to give a shape to the performance. I'm not sure how much this is clear, but this is more or less an overview of the interactions of the different parts of this environment. So the iPhone app works more or less like this. It creates virtual bodies are linked to samples. So actually, these drone trajectories can be followed back by the performer, and they will always sound the same. And we have three different types of virtual bodies, which are linked to three different types of sound. So the yellow sounds are more voice-like, those low sounds you were hearing at the beginning. And then the blue sounds are more like pointy, will generate inside the application pointy, high-pitched sounds. And the red virtual bodies will generate through OSI connection to the computer, will generate breathe-like inharmonic sounds. Now, as you can see, in this case, the screen is divided in 4 parts, one for each instrument that was taking part into one of the performances. So I kept this outline for this presentation. And basically, as you can imagine, I will talk more about this later if I have time. Depending on where these virtual bodies fall inside the iPhone screen, the performers in real time will read and perform sounds according to. In addition, this the performance following this environment was developed through a a year-long class at a university in Hong Kong. So there was quite a lot of time to rehearse and explain. And this application was conceived in that way, was conceived to be something that you can rehearse on and that can have enough points of interest to actually create a complex situation. So it's not something that you will play like straight on and will always be the same. And then the iPhone on the headset is used to spatialize in a 3D sound environment the process sound of the different instruments. So you were seeing, for example, there was a voice, clarinet, violin, and piano. Each of them is processed on a different channel, and each one of these channels can be then controlled by this headset app and be specialized in a 3D sound environment. So here, for example, if you were using the headphones, you'd hear the spatialization because I recorded this in binaural. Anyway, essentially, you can draw these trajectories around and the spatialization of these objects will follow. And this is the Ableton Live project. So you can see each instrument has a SPAT channel. The SPAT channel will actually deliver to a set of stereo tracks, because that's how Ableton works, will deliver as an output the spatialized signal. The spatialization is done with a SPAT. Here comes SPAT, using a vector-based amplitude panning 3D algorithm. Now, coming back to the score, as I said, so for the iPhone performer, what he draws in space or she draws in space is actually a gestural score. As you can see, in fact, here, by following the same trajectory, you get always the same sound. So that's like one first step. And while for the performers, for the other performers that are not the iPhone performer, this is instead three-dimensional graphic score that they need to interpret, and I will say in a bit how. But basically, they can consider their quadrant as one loop of 5 seconds, and they should read that entirely, like left to right in 5 seconds, or other timeline, if agreed. For example, oh, sorry. Oh. Like the yellow samples are long samples also. Basically, you can use Super Bowl on low strings or produce some voice-like sounds. And then for for the blue samples or marble samples, plucking with nails on strings, producing these high-pitched, slightly inharmonic, fast attack sounds. And for breathe samples, or let's say the red samples, you can use rattle-seeking magnets on the metal board, play on the on the keyboard in the style of Lachenmann's Gero, etc., etc. So it's like these sounds. The idea is that each instrument.
So, Giovanni, we are running out of time, so you can finish up quickly and we'll take some questions.
I will wrap up in 30 seconds, and we can go on with questions, please. So basically, the idea is to use inharmonic, or is to use extended techniques to produce this kind of sounds that are related to the sounds produced by the iPhone, basically. This was the performance outline. I will not go into it in detail on this. And thank you.
Thank you, Giovanni. All right. Do I have any questions? Yeah. Sorry. Okay, yes.
I'm sorry. Can you please write the questions in chat, if any, because I really don't hear very well.
Hello, Giovanni. Can you hear me? Giovanni, can you hear me?
I can hear, but the audio is very distorted. If you can, if there is any question, if you can write in.
Yes, I have a question for you. Can you please give more detail on the performance level, please?
Can you please write the question in chat, because it's very.
You said I don't have time to explain the OMUs that the performance situation. Can you please take that time now?
We'll write in the chat.
Yes, sure. Let me for this go back a couple slides and show you also like a concert situation. So basically we are having two screens. One is showing the iPhone screen, the other shows the headset. So that's this is the, oh sorry, yes. Yeah. So basically the performers are reading from here, while the iPhone player will read from his own screen and will refer to the performance outline. So basically it will say start with blue bodies, and these blue bodies are steady for a bit, and then we'll get more excited later, and so on and so forth. I think the indication is quite straightforward for what concerns the performance outline. It's just colors and excitement. And this is how, and the dynamics is how full will be the screen with the virtual bodies, basically. And in this case, for example, if we take this moment, we will have only piano and piano and a violin. Sorry, it's not always very well readable, this image, but that's all what I got. So in this case will be only piano playing for most of the time in a 5-second loops, a brief-like sounds, and then there will be violin just at the beginning of the loop, playing very shortly a sample, a crack or something like that. But of course, as you can see, the score is very fluid. It moves very much on average. It depends on the performer though. Of course, it's not that clear always what happens, but let's say if you could see a full time performance on average, it would work quite as expected. While here on the other screen, you are seeing all the trajectories of the different bodies, virtual bodies, and therefore the trajectories of different process sounds of the different instruments. Is this enough? Last slide, evaluation. Or
Thank you so much, Giovanni. We need to. I'm sorry.
Yes, if I can explain on the evaluation side. Okay. So
no, sorry. We need to move on now to the next presenter.
Okay, sure. Thank you very much.
Yeah, thank you, Giovanni. Thank you so much. All right. Next speaker is Anna SHVETS and Samir DARKAZANLI with Conditional Semantic Music Generation in the context of VR project Grads in Harmony Learning.
Thanks.
There you go.
Okay, perfect. Okay, so let's start. And I can, okay, like this, perfect. Okay, my name is Anna SHVETS, and I'm a industrial researcher in the domain of natural language generation. While holding my PhD in computational musicology, I'm applying those deep learning techniques in the semantic music generation, and together with my collaborator, Samir DARKAZANLI, who's a programmer at the IT company in the Toulouse region, we've built a VR project for learning harmony, which integrates those models that we were developing so far. So what is the motivation for this work? A recent study on the use of the AI in learning revealed the very little evidence of the pedagogical theory behind. And another meta study, which included 250 articles that appeared in the XR in music domain during the last 30 years, shows that if the VR application or XR application is applied in music learning, it's always tightened with it's always coupled with the particular grid of a particular instrument, which limits the usage of this application for students, for example, who are not familiar with that instrument and for whom that just creates the additional cognitive block. And lastly, the recent context of the pandemics that forced the distance learning showed that the video conference format of courses lacks the immersive and practice. So in this presentation, we tried to give our solution to that problem, presented the VR application for learning music harmony that is based on a new system of representation, so the system of graphs, which uses the AI models in a pedagogical way, so for creating the dynamic content for the testing and practice rooms. And we also discussed the new encoding method and experiment that related to that, which actually allows which betters the generalization capacities of those generative models. So let's start with the graph representation. This formalism, before being applied to VR domain, has given a way to mobile and web application that being applied to the pedagogical process and gave very promising results. So what is the graph? The system graph is based on the notions of frame scientist of the 20th century, Minsky, who said that frame is intended to represent the stereotyped information structure, which in music harmony corresponds to the passing progressions, where the sequence length is always 3 chords. The first and the last chords have 4 tones, so they are always 7 chords, and the middle chord has always 3 tones, so it's very stereotyped. Moreover, there will be always 3-side fetch possible between two 7 chords. So if we fill those frames filling with the information about all possible passing progression in the diatonics, we see that the horizontal alignment of those graphs is based on the similar information in tops of the graphs. So the 7 chords. So here you have the ground state, first inversion, second inversion, third inversion of the 7 chords. And the vertical alignment in the system is based on the same information in the vertices in the graph. So here we have the same passing progressions. So the whole system comprises the chords of 7 degrees of the diatonic scale, and it is finite. Meaning if we try to build it further away, we just will repeat the information that is already present here. The formalism contains the second element, which is the augmented score representation with the color mapping. So the color is mapped to music function groups, so subdominant, dominant groups, and the color shade is mapped to the chord structures. So this facilitates to visually repair, especially in augmented position, the ground or the fundamental tone of the chord. Taking all together, this element along with the systems of graphs, it lifts the cognitive load for the student, and it actually allows him or her to focus on the audio material, on the phonism of the chord. There were 3 experiments that were led in the institution in the universities in Poland, in France, and we see that this method being applied to the experimental group, here marked in blue. Each time in the after experiment test, the experiment group has better results regarding the overall assessment and quality of knowledge, comparing to the control group, marked in red, which didn't have those elements introduced to the learning process. So let's see how this all was applied to the Vieira application. So following this pedagogical success, the system has been applied to the user interface construction in the Vieira application graphs in music harmony. This project has several years already, so it was presented to other venues. And here the panoramic view of the virtual spaces the application has. So the entry, temple of knowledge, study room, test room, practice room. Let's see first the basic functionality of the
application is divided into multiple rules. The first rule is a welcome rule. It gives basic information for navigating inside the application. The second rule, which looks like a temple, gives information about the graph system. It explains the representation methodology, the scoring representation, and the vertical and horizontal trials. Deductions illustrated in this part are necessary to benefit from the experience. A study rules allow the user to discover the graph system. Both horizontal and vertical trials can be displayed. In this example, the user explores a specific horizontal trial. In this other example, the user explores a vertical trial.
Yes, the sound very quiet. Yeah. I don't know how can I do this.
Maybe at your computer.
Minus 100%. Anyway, well, there are the sounds of those chords actually being played. So let's return to the presentation mode. Okay, that was the main functionalities that were not related to the AI, and now let's see the test room and practice room that are based on the generative models. So this one.
When the VR application receives a prediction of the third chord from the AI model, it plays the corresponding harmonic progression. Then it asks the user to choose between the button tops and the graph. If the user chooses a correct graph slot, the chord is rendered in a dimensional score representation. In case of an incorrect answer, the user receives feedback from the communication board, and the correct chord is not revealed. The user can again generate the question to work towards a correct answer.
Okay, and finally the practice room, where the model generates the not only one chord but the entire sequence, which is conditioned by the user input. So the first chord is the class that will be taken by the model to generate the entire sequence of 5 chords. So here the user chooses the subdominant 7th chord, and it appears as the first chord of the sequence. So let's see how those models were deployed and integrated the VR model. So the main goal, if you may say, for those generative models development was the project restrictions. As you can see, this content, for instance, is available only in C major key. So all the mappings can be done only in C major, and it has to be diatonic. The other another requirement is that it should be the harmonic sixths only, and so no melodic or polyphonic movements. So I can take like the embeddings of the trained model and use it because I had to follow all those restrictions. And so the application was deployed in the remote Heroku server inside a fast application, which was handling the HTTP requests. And the communication protocol was JSON data. So the input from the user came as a condition to the model. Model was analyzing that, making a prediction and returning it into the JSON data. Here I see the example of this JSON data return. It returns one chord, and yeah, so prediction is true. And the mapping is done the model, the architecture model that is used in the test room. So it's, as you could have seen already, is generated the third chord, while 2 chord conditions chords are given. So they are given by the application itself. So it's for the renewal of the test material. For as a data, it was only the path progression used, so it was very limited in terms of the data that was trained on. For the second model, which was using a practice room, a conditional gun was developed. It, by the way, it was the first conditional gun with the convolution of 1D layers in semantic generation domain. And it was generating the entire sequence of 5 chords, as you also have seen, when the first chord conditioned by the function of the class, so it was given by the user was chosen, and the application was taking that as an input and was generating the 5 chords behind. So to train this model, we used the data from the KIM-BOYLE dataset classical music, processed with the Music 21 Python library for computational musicology. And discriminator. Finally, to push further our research and improve the performance of models, we made the experiment on sequence being a representative of 1D information, right? So there are 3 chords being represented into these bits, receive its X and Y coordinates. So we can transform into the metric representation, and such a way we can augment the dimensionality of data. As a result of this transformation, we receive the matrices of 28 around 28, where those 4 matrices representing the 4 chords as an input and the fifth chord as a target. And we also, this presentation, this kind of representation, this kind of content allows the data, artificial data augmentation, where we are planning in random relation term function, where the metric value that you receive as a chord representation, it's a chord index divided by vocabulary size, so the number of unique chords in your data set, plus x, and x is a scalar in a range between 0, 1 and 0, 0, 1, which allows a small variation of data for metrics, and it is better for deep learning, while the sequences are actually remaining the same. Okay, and very quickly, the experiment results. So in order to see how this data dimensionality augmentation and data augmentation in general affects the performance of the model, we tested the 1D version of the data with LSTM. So here is the picture, and 2D version of the data with conv-LSTM. So convolution LSTM, which has a convolution layers in it. And we saw this is representation. So this is the model trained on LSTM, conv-LSTM, non-augmented and augmented. I maybe go straight forward and show you the result of the key-fold. So key-fold validation method, which allows you to use different partition of the data set and train basically the number of models defined by key. So here it was 10 models in each category, and then you take the mean value of all those model trains. So we basically train here 30 models on different partition data. And as you can see, the LSTM tends to have worse, let's say, validation result, because it is expected that the validation value of the loss diminishes towards the end of training. And here we see that in the beginning it was slow and then it augmented. While the conv-LSTM, it actually followed the strategy. So in the beginning it was big, and in the end it was small. And when we applied the data augmentation, that with this normalized term, we could even see that the loss function is even lower than the traditional LSTM. Just one last slide. This representation, this 2D representation of harmonic sequences and the data dimensionality augmentation allows to visualize those matrices. So it allows to explain why the model takes that or that decision while doing the generation. So these are the output gate filter visualization of the first and second layer in the convolution 2D layer. So finally, in conclusions, the encoding based on the system graphs allows 1D and 2D representation of the same data, which makes it possible to investigate neural networks training efficiency from the ambivalent perspective. So it's good for neural network research in general. Semantic data dimensionality augmentation allows application of architecture evaluation strategy inherent to visual domains. So we can visualize the filters, we can use the validation metrics that are already existent in the visual domain. It has been shown that the dimensionality augmentation improves the generalization capacities of the model, as you could see. And the application of the variant normalization theorem for data augmentation gives lower training and validation losses and improves the generalization capacities of the neural network. So thank you for your time and attention.
So, so you have some deep learning algorithms, and then a tool that is VR application.
Yeah.
Could you clarify how those two parts of the system interact with one another?
Yeah, sure. So I just return to this part. Maybe it wasn't clear when I was presenting. Yet. Almost there. Yeah, here we are. So the model, when it was trained, you receive the binary file, right? This binary file, then integrated to the Flask application. The Flask application is the interface which is the interpreter between Python code and the HTTP requests. So the HTML and etc. So being integrated to this Flask application, it was deployed to remote server. For instance, it was Heroku, so it was test server, but in production, it maybe any commercial server or even even backend, so a commercial backend that handles the requests. So basically, the VR application, when the user was choosing the court, the application generates the JSON data, right? So it generates court like this, request like this, and it sends to the application, to the server, right? So it makes this REST HTTP request and makes it to the server. Then the application on the server processes the data. It generates the sequence, the court, or the sequence depends on the task, and it sends back as its prediction in the same using the same data protocol JSON. So here is a prediction is the third court. So this is our value that our application then maps to the score. Yeah, so that way.
All right. To the last speaker, which is
Okay, thank you. Hopefully I'll have less drama during the screen this time. So here we go. I can't share my screen because it's being shared from the conference room. So somebody please stop.
Hello.
So I'm unable to share my screen at the moment because I'm looking at someone else's screen.
Maybe you can throw, is it Zoom? You can throw out anyone who is in.
Draw out.
but we're not sharing from anywhere here.
Oh, sorry.
Could you try to monitor it?
Awesome. So hopefully you can all see my screen. Sing out if you cannot. Good. So real color. This is the first work of mine that's been specifically developed for virtual reality. I've had quite a lot of experience doing AR work, but VR work was its own special challenge. So I guess the first thing to talk about is this title, 96 Postcards in Real Color. Well, it comes from the work of Georges Perec. Hopefully most of you have heard of Georges Perec. In 1978, he had a piece called 243 Postcards in Real Color. And these postcards were basically little texts that were from a particular location. They described a particular activity, and they ended with a farewell. So you can see an example of 3 of them, obviously in English translation here. I think the translation is by a gentleman called James Sturrock. So these are 3 of them, 3 of the 243 Postcards. Now, Georges Perec, most of you also should know, hopefully, is a member of this loose assembly of writers called the Ulipo. Probably most well represented by Perec, Italo Calvino, Raymond Queneau. And this assembly of writers was really interested in combinatorics and constraint-based creation, using lipograms, palindromes, permutations. Perhaps some of you have heard of Georges Perec's famous work. I can't remember the name of it, but in the entire book is quite and it's not necessarily a school that's been limited to literature. There are similar schools in various art forms, including music, photography, other visual arts, sculpture. They're out there. So what I was really interested in doing when I was thinking about this work was developing something that kind of contemporized some of these techniques. And so I was thinking, well, what's the modern equivalent of the postcard? And for me, it's kind of Instagram. I don't use Instagram very often, but I thought it'd be really interesting to develop a piece that had a score that was based on data gathered from Instagram locations. So I basically look at 96 locations around the world, and I generate an immersive score, an immersive visualization. And I'll show you what that looks like later. But it's a score that's presented to the performers, to the singers in virtual reality. And it uses the Oculus Quest 2, which is kind of my headset of choice for VR development. So Instagram scraping, and here comes this term again, scraping when we're gathering data from social media, is normally facilitated through the API of a platform. Unfortunately, though, in 2020, Instagram deprecated its API, or its public API at least. So you can no longer automatically scrape data from Instagram. Data, which is useful for business analytics, marketing, and things like this. So this is a real challenge. How do you get data from Instagram when there's no public API? Well, you can do it, but there are risks involved in this, because if you do it with your if you happen to love Instagram, you risk losing your account. So when I was developing this work, I created a dummy account. Because this is being recorded, but it's a violation of the terms of service to scrape any data from Instagram. So that's a risk. However, you can do it with a couple of Python libraries, and I'll give you a live example of this. Hopefully it will work, called Selenium. Selenium is basically a library that lets you automate tasks, and it works through the Chrome driver, and I'll show you this in a minute. So Selenium was kind of critical in getting the data that I needed for this particular work. In addition to Selenium, another library which is really useful is called Beautiful Soup. And this is basically a library that lets you pass HTML data. So it's really useful because Selenium is essentially pulling HTML data and Beautiful Soup is analyzing it. So let's have a look at how this works. And fingers crossed it will work. So I'm just going to quit the sharing and then I'll come back into the sharing again. Okay. Okay, here we go. So let's see how this works. Fingers crossed. So this is the all of the Python script, and unfortunately, some of the functionality has been deprecated in the past week. So some of it may or may not work, but we'll find out. And it doesn't look like I'm going to have much luck, but I'll just restart my kernel, and we'll see what happens. I have a backup in the event that this doesn't work, but. There it is. Okay, so I have this pop-up window, which is on the left-hand side of the screen, and these are my dummy accounts, so I don't care really if this account gets banned. And basically, I can just automate a lot of the processes for searching. I'm trying to make sure you can see everything. So I'm dragging around things here. So I'm automating a logon right now to Instagram. Now there's a little bit of a issue here with something that's been deprecated. So I'll just do a not now on that button and a not now on that button. Now that has actually been automated here, but for some reason it's no longer working. So I can do a search on Instagram on the location Cyprus. And hopefully in the background, there we go. So these are all of the posts, most recent posts on Cyprus. And we can basically look at the URLs of all of these posts, scroll through them, send all coming from this live feed. So there you are. So this is what's going on in Cyprus right now. It looks very nice and sunny. And so that's basically the process of gathering data from Instagram. And when it's done, I'm basically writing a CSV file, which is here. And this CSV file has all of the URLs, which I can use for reference, and it has the caption data that comes from each of those associated posts. So that's the basic concept of how I'm getting data from Instagram. So I'm just going to stop that and just jump back into my PowerPoint. I'll close that off and go back into PowerPoint. Back one, and this is actually all of the results here. So for this particular work, 96 postcards in real color, I have 96 locations around the world, one for each letter of the alphabet in a true kind of Perec style, I guess. And you can see all of the cities here, A through Z, 3 times. So 3 different cities. And yeah, so these are the captions here, Instagram locations. So basically, this is the data, and there was quite a lot of manual parsing going on here because it takes time to gather all this data. It's not something, unlike Twitter scraping, that you can really do in real time. One of the risks as well is that often on Instagram, you have if you're trying to develop a score that's using language or using text, emoticons aren't really recognized in most natural language processing libraries. So that unfortunately required quite a lot of manual sorting to go through and pull out what wasn't useful. Language was also an interesting one. So anything that was coming in or Japanese or Hindi or some other language had to be filtered out. So once I had all this data, the next question which really presented itself, similar to the Twitter work, which I spoke about earlier, was how can I visualize all of this? And how should that be interpreted? And again, these are kind of questions that force reevaluations of each other. They're not self-contained questions. So there were some kind of a priori considerations in this work. And these included, I wanted the work to feature an immersive open score. And this is the score on the left. Well, it's actually a screen snapshot from the Unity development platform. I wanted to have what I like to refer to as a derive model of performance. And I'll talk about that in a minute. I also wanted a particular design aesthetic. Some of you have seen some of my graphic scores, and they generally feature nodes, which represent musical events connected to other nodes by edges or lines. And this is a 3-dimensional score. And the best way to explain the kind of model of performance is perhaps by looking at a previous work of musical events represented by nodes connected to other nodes. The color of nodes represents pitch. The distance from one node to another represents the duration of a pitch. And essentially the performer using this derive model, which is a term from Gilles Debord, for those of you who haven't heard that term before, involves working through the score. The score in this sense is presented as a 3-dimensional object, and performers are free to explore different pathways through the score. So the performance in a sense becomes this kind of geographical exploration of this visualization, I guess. So that's kind of design aesthetic, I guess. So I wanted an immersive score. So that basically means, of course, that the score surrounds the performers. And so that's one of the kind of the a priori considerations here. This is a schematic, a top-down bird's eye view schematic of the score on the right-hand side. In 96 postcards, the performers are surrounded by 12 panels, and I'll give you a close-up of one of these panels in a minute. And essentially during performance, and this piece was supposed to be performed tonight, but because I've been unable to make it, its performance has unfortunately not been able to go ahead. Nevertheless, in performance, performers explore their way around the 360-degree circumference of the score. And it looks something like this. So all of these images that you see in the background here have come from Instagram. And we see a visualization of that particular text caption in the form of a node line construct at the front. I'll just let that play for a bit. This is a movie screen recording capture from Unity. If I have time, which unfortunately I don't think I will, I could show you the Unity example itself, or even better, Oculus casting, but I don't think I'll have time for that. So basically what we see here is a visualization of these text captions down below here. The images themselves are not analyzed, or sorry, they're not interpreted, but they do provide a useful anchor for the performers as they navigate their way through the work. The score itself doesn't animate like this. It's actually static, but this just is an example of how the performers might see different aspects of the score as they rotate around a static position. So one of the things I really struggled with this work was how I was going to map text data to the graphic score. And I think one of the things I struggled with mostly was what to do with node colors. And originally I had thought, well, maybe each vowel can have a different color, or a particular type of word. If it's a verb or if it's a noun, it can have a different color. But this so basically what I did was have a particular distribution of nodes. And in this particular case, in this work, again, color represents pitch, but pitch is kind of redefined in this harmonic mapping around the circumference, according to this kind of distribution that you see here. So we'll just move along. The text, on the other hand, as I mentioned, is presented at the top of each panel, and we have only one caption, which is randomly selected. This particular text you're seeing now is actually not from Instagram. This is just for development. This is from the original text of Georges Perec. The text is used, however, for the performers as indicating a type of enunciation. How is each of these pitches represented by a node to be enunciated? And they use the vowels that you see in each caption here. So sequencing through this particular caption, they would be choosing E, A, E, O, E, E, U, A, cycling through that. I decided to use text rather than any particular type of graphic representation because people can read more quickly than they can interpret a graphic symbol. So very quickly, the work was developed for the Quest and 4 quests, well, a minimum of 4 quests. Most VR development is developed for single person experiences. So this was something that was a little bit of a actually facilitate that, how you manage that is an interesting challenge, I guess. And I have done it through a particular library called the Photon Library, which basically facilitates all of the synchronization. I only have a little bit more.
Running out of time, so if you could
I only have a couple of So I use the Photon Unity Networking SDK, which basically synchronizes a VR scene across multiple Oculus headset devices. So basically what this means is that I can ensure that each of the performers wearing a separate headset is looking at the same scene. So that was really important for me. The other thing that was real important consideration is this whole field of UX, and people have developed careers on UX. So I'm not going to be able to go into any depth here. But there are various common things which are always important when developing VR work, such as the rate of object movement, the resolution of objects, the need to make sure that people are safe when they're in a VR environment. One thing that gets a little bit less attention is the use of text. And here's some interesting data on VR headsets, or a comparison of resolutions. And this has a direct correlation to the size of text that can be used in any score. So for the Quest 2, if you want fonts to be legible, you have to use 40-point text, which is quite large, but it's required in order to be able to see it. I don't think perhaps I can wrap it up there. And there's more details in the paper. If anyone has questions that they'd like to ask, I'm happy to take them.
David, I'm really curious about the way to transfer text into scores, and you said that you use NLP algorithm to give a special distance between the mode from the caption of the Instagram caption. So what's your idea here? Because
yeah, so I didn't have much time to go into it in detail there, but basically I'm using a combination of techniques, essentially looking at the vowel location. So I'm mapping vowel to the spatial location of a node. So that ends up affecting the duration of a particular pitch. I use spacey a little bit for structural information. I didn't look at spacey today, right now, because I looked at it a little bit more in the previous presentation, but basically I'm using spacey and just some number crunching in the C# scripts, which are used in Unity environment. I hope that gives you a little bit of an answer there.
But thank you so much, David, for your presentation. All right, and that wraps up this session on VR, AR, and 3D. And now there is a coffee break. And thank you so much for being here.
Just take a start. The performance
Yeah, I work with the guys for companies called Conditional. So app VR, where you can build your own instruments and do musical and visual performances. So, yeah.
And it was on workshop, right?
Yes.
Right. I really wanted to see actually. Or other foreign students.
No, unfortunately not, but tonight.
Yes.
Jonathan, he will be using
Yeah.
during his performance.
I was really interested how you organize these, how do you integrate? What is the shapes and how you manage that? Because normally you have a lot
Donc ça c'est le micro de gauche, de ma gauche, 1, 2, 3, test, 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 1, 2, 3, 1, 2, 3, j'ai mon téléphone portable si vous avez besoin de communiquer, ça 1, 2, 3, micro 1, et là micro 2, 1, 2, 3, micro de droite, 1, 2, 3, est-ce que si je me recule c'est mieux? Là, je me rapproche, 1, 2, 3, là, je me recule, 1, 2, 3.
So if more si je fais comme ça. And the entire process of building and making worlds and instruments all happens within the same app. So literally just grab stuff and place it wherever you want to.
Ah oui, en plus, tout est enregistré là. Donc je teste le micro. Hein. Il n'y a pas moyen d'en couper un sur les deux? Parce que ça multiplie les saturations en fait.
Tu nous entends, Vincent?
Je sais pas. Est-ce qu'il y a un changement qui s'est produit ou pas?
On va voir. Bon là, je teste le premier micro. 1, 2, 1, 2, 1, 2. Test premier micro. Test 1, micro 1, micro 1.
Il est muté, non, Vincent?
Oui, il faut qu'il s'installe. 1, 2, 3. Est-ce que tu m'entends, Vincent?
Ah.
Qu'est-ce que ça donne, le micro? 1, 2, 3, 1, 2, 3.
Ça sature autant.
Ça sature. Et celui-là, est-ce qu'il est mieux? 1, 2, 3, 1, 2, 3. Est-ce que ça sature aussi?
Pareil.
Ça sature?
Et si je les éloigne? Si je m'éloigne, est-ce que ça sature? 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. 1, 2, 3. Test, 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 test.
On t'entend pas du tout. T'es pas mute, toi?
Non, je suis...
C'est peut-être ton réseau. Ton réseau qui est peut-être pas terrible?
Ben non, je suis...
Ah, c'est bon. Ouais.
Moi, j'étais baissé là.
Donc, ça sature chez nous, c'est ça?
Ça sature toujours en zoom.
Ok.
Bon, et si tu éteins celui-là, est-ce que c'est mieux là, celui-là?
C'est pareil.
3. C'est pareil, et si je baisse complètement le niveau?
Le niveau de quoi? De sortie?
Le niveau dans la salle. 1, 2, 3, 1, 2, 3. Qu'est-ce que ça donne là? Est-ce que c'est mieux?
Je pense pas que ça soit ça. Il faudrait qu'on ait accès au niveau d'entrée du micro. Ça, je sais pas si on peut.
Est-ce que c'est... J'ai pas entendu ta réponse. Est-ce que c'est mieux?
Remonter du coup, parce qu'on n'entend pas.
Pas mieux, mais on n'a pas possibilité d'avoir accès au micro d'entrée du micro? Au niveau d'entrée du micro?
Ben, je sais pas, moi,
Je crois
justement,
pas.
c'est ça le problème, c'est que...
Est-ce que le micro dans lequel je parle, c'est mieux? Tu m'entends bien ou pas? C'est pas mal? Ouais? Ok, lui, il a l'air pas mal, ouais, du coup, comme micro, là.
Lequel?
C'est, je sais pas si tu me vois, là. C'est, micro qui est sur la table de devant, là.
Et le micro de gauche ou de droite quand on regarde l'écran?
De gauche. Je peux essayer celui de droite aussi?
Ah, là, je te vois.
Ouais, là tu m'entends bien, là?
Oui, c'est pareil.
Oui? Ok. Bon, bah, il faut peut-être essayer ces deux micros-là, alors.
Et là, quand on mute le micro, ça fait quoi ici?
Juste le volume, le gain.
Non, il y a un micro qu'on peut couper.
Bah, je pense que ça mute.
Ça mute quel micro? Ça mute quel micro? Non, bah là, j'ai appuyé, ça n'a pas muté.
Ah ouais?
Et est-ce que c'est meilleur si...
Là, t'es pas mute, là, non?
Non, mais quand je fais ça, et que tu nous entends quand même.
Tu m'entends, Vincent? Est-ce que tu m'entends? Ah oui, ok.
Et ça donne quoi, le son?
Bah, Joséphine sature, mais Adrien, ça va.
Ah, voilà. Donc, c'est ceux-là qui saturent. Donc, il faut enlever ceux-là, hein. Et si on les enlève?
Non, mais il faut les enlever.
Il était là.
Ah, il est où, le bouton?
Je parle plus loin des micros. Si les micros du pupitre.
Ah, j'ai pas vu. Ben voilà, et si on coupe un des deux?
Il était déjà coupé, oui.
Sur les micros du pupitre, si vous les mettez légèrement en arrière, est-ce que c'est mieux?
Et est-ce que celui-là, si je mets que celui-là, parce que tout à l'heure, j'avais
que celui-là tout à l'heure.
J'avais de l'amplification sur celui-là aussi, hein, quand j'essayais, mais bon, c'est pas grave. Si celui-là, est-ce que c'est mieux si je l'écarte un peu? Est-ce que c'est mieux comme ça, le son?
Mais du coup, on ne s'entend pas dans la salle.
Essayez de mettre le micro plus loin, c'est-à-dire pas trop mettre 50 cm plutôt que 20 cm.
Oui, là, je suis plus loin. Je suis plus loin, là. Est-ce que c'est mieux?
C'est ultra saturé à chaque fois. J'ai l'impression que c'est au début des phrases, c'est pire.
C'est le niveau qui part sur Zoom qui est saturé. Vous ne pouvez pas gérer le son qui part sur Zoom. Vous n'avez pas un...
Mais c'est déjà réglé. Quand on n'y arrive pas, ça vient du réseau et nous, on peut rien faire là-dessus.
Vous n'avez pas du tout... Vous ne pouvez pas régler le niveau en sortie?
On peut le baisser.
Ah bah oui, le niveau qui part vers Zoom, on ne peut pas le baisser. Ah non, je ne parle pas de l'amplification ici. Ça, j'ai déjà essayé de baisser. Ce n'est pas le problème de l'amplification, c'est le niveau de sortie ligne qui part vers Zoom.
Non, ça ne changera rien. On a déjà fait ça. Ça n'a pas marché.
Ça sature aussi.
Ouais, pareil. Exactement.
C'est un problème connu.
Mais alors, qu'est-ce qui va pas alors?
Ah, il y a quelque chose, c'est l'opérateur qui.
Les paramètres. Les paramètres. Comment on peut gérer d'entrée du micro sur Zoom?
Ça marche très bien. Ou dans l'après-midi, ça marche.
Ah oui, c'est pas reproductible comme problème. Ah ouais.
Le problème, il est là.
Des fois ça marche, des fois ça marche pas.
Voilà.
Bien, ça marche.
Ça marchait bien le son qui partait vers vous.
Bien, vous savez passer, pas la journée, mais il n'y a pas, voilà, il n'y a pas eu de problème.
Joséphine, est-ce que tu m'entends?
Oui, on t'entend.
Et si tu parles plus loin du micro, encore une fois, si vous mettez les micros sur les micros du pupitre, vous les retirez vraiment.
C'est aussi que les gens dans la salle, ils n'écoutent pas si on est trop loin.
Oh, si, ils entendent quand même.
Attends. Est-ce que tu nous entends quand on parle comme ça, Vincent?
Là, c'est bien, oui.
Ok, parce que là, du coup, il y a juste les deux micros rouges qui captent et je suis loin des micros, là.
Ouais, on est.
Tu comprends ce que je dis?
Parfaitement. Parfaitement.
Et par exemple, ça se pas là.
Et c'est pas saturé là.
Bon.
Si je me mets là, tu comprends ce que je dis?
Bah oui.
Ah ok, bah voilà, en fait, c'est bon, il y a. Voilà, si je peux poser une question.
Bah oui, du moment qu'il entend dans la salle.
Oui, oui, bah là, de toute façon, il faut passer un peu la voix, effectivement. C'est une possibilité.
Après, les gens, s'ils n'ont pas de micro, ils vont parler plus fort. Là, on m'entend quand je parle dans la salle. Bon, bah voilà.
Peut-être qu'un des deux, on peut l'orienter vers le pupitre si la personne veut parler au pupitre.
Mais celui-là, il ne faut pas l'utiliser. Hein, c'est
non.
Voilà. Éteint.
J'ai récupéré mes fils.
Dans la salle, vous entendez?
Non, mais si on met les trucs loin comme ça, est-ce que c'est quand je parle loin du micro, c'est supportable?
Il n'y avait pas de pile, donc j'en ai ramené puis là.
Vincent.
C'est
bien? Je t'entends pas.
Ouais, c'était plein, ouais.
C'est mieux? Ah, il dit que c'est mieux si on est loin du micro. Si j'en enlève.
Comme ça, pas de problème avec celui-là.
Comment on les éteint, ceux-là?
Ah, monsieur, tu peux les allumer aussi, non?
Oui, non, mais je regarde avec un seul pour voir ce que ça donne. Et là, s'il n'y a qu'un seul, si je mets qu'un seul micro, je suis à 30 cm, 50 cm du micro, on entend dans la salle, et toi, tu m'entends bien.
Il est un peu figé.
Non, il y a très peu de saturation. Il y a encore un chouïa de saturation, mais c'est tout à fait acceptable.
Acceptable. Bon, bah écoute, on va faire comme ça. Hein. On va
moi, si je pose ma question d'ici, tu l'entends bien?
Je les laisse allumer alors ou pas?
Est-ce que tu as entendu Adrien te parler?
Tu as entendu ma question?
Oui, à peu près.
Ok, bon.
Bon,
là, je suis vraiment à l'opposé du micro.
On touche à rien. Ce qu'on peut faire, c'est qu'on fait semblant. On leur donne le micro, il faut semblant d'avoir. On leur dire que ça entend.
Mais peut-être qu'on allume le deuxième quand même, non? Ou...
Lequel?
C'est mieux avec
le deuxième.
On va essayer avec le deuxième.
Après, on peut tourner un vers le public.
Ah ouais, et un vers le public.
Ouais.
Ah ouais. Ah, mais il y avait déjà des problèmes.
On a pas d'avance. La voiture, ça va? Pas sur le réseau, après, sur l'opéra. C'est moi qui commence, c'est pour ça que je suis un peu avant pour vérifier qu'il n'y a pas de problème.
C'est pour Zoom qu'on galère parce que sinon on a un problème. En réalité, ça passera pas ce micro-là.
Non, on peut essayer surtout de voir ces histoires de double écran, parce que c'est plus agréable de pouvoir présenter en ayant. Donc, c'est la configuration que vous laissez. Mais pour Zoom, je suis obligé à chaque fois de descendre la salle.
présentation à l'extérieur et de réallumer la salle.
Oui, pour le partage d'écran, c'est ça?
Ouais, non, non, non. Quand il y a une communication en Zoom, je suis obligé d'éteindre la salle. Je suis obligé de désactiver. Ah, le micro de salle?
Alors.
Ah ouais, ça fait un jeu. Normalement, c'était un retour. Normalement, il y a pas de. Parce que toi, quand tu parlais, là, il n'y avait pas de retour, hein, on t'entendait. Et ça, ouais, ouais. Pourquoi tu ne t'entendais pas en retour? Là, il y avait les micros activés.
Vincent, j'ai accès à l'écran là, tu penses?
Ah, oui, c'est bon. Alors, il faut appuyer sur en haut à gauche, tout en haut à gauche.
Contenu partagé?
Ouais, c'est pareil, il est sur le programme.
Ah, super. Ça, je vais vérifier qu'au PowerPoint,
Est-ce que ça vous embête pas de vous
D'ailleurs, le micro, pourquoi il est désactivé?
Parce que le micro là, il.
Ah, moi, je me mets où tu veux.
Non, non.
Si,
Ça marchait, celui-là?
Moi, je veux bien qu'on reteste le micro, mais celui-là était meilleur que celui-là.
Mais ça marchait pas d'ici?
Si, ça marchait mieux d'ici que là, le son.
Mais en parlant d'ici ou pas?
Deux.
Là, ils sont désactivés ces micros-là.
Ah, tu préfères
problème. Mais
On essaye comme ça, mais.
Moi, tu me dis, donc je me mets.
essaye comme ça.
attention.
Il suffit que je arrache pas tous les fils.
Si ça marche d'ici ou
On a essayé ce micro-là.
Non, mais.
Le son.
Mais du coup, lui, là, il n'est pas amplifié dans la salle, quoi.
Ah, eh oui, t'as raison. Moi, j'en sais rien. Moi, je me mets où vous voulez.
Il faut que la salle soit bien. Hein, parce que...
Oui, la
Mais ça passe un peu dans l'amplification.
Ah, c'est bon, là.
Oui, c'est important.
Là, vous m'entendez? Ouais, cool. Non, c'est les micros. C'est un, ouais, d'accord, c'est un micro assez sensible.
Oui, très sensible.
D'accord.
C'est quand même dommage parce que c'est beaucoup plus simple.
Et oui, le son de ceux-là est pire que le son est meilleur là. Quand j'ai essayé, tu m'as dit que c'était correct. Alors que là.
Alors, ce que je voulais voir, tester avant, c'est le double écran. Alors, un moniteur principal.
On peut se faire un test. Un test de partage.
Alors, attends un peu. Ouais, ça, c'est pas dans le bon sens déjà, c'est à l'envers.
J'ai tout le temps ce problème-là.
C'est pour ça que je le fais avant, tu vois, parce que c'est jamais dans le bon sens. Voilà, c'est dans le bon sens.
Il faut switcher entre
Voilà, c'est ça.
les paramètres.
C'est ça que je voulais vérifier, tu vois. Un truc que je veux vérifier aussi, quand même, c'est le son. Attends, je peux le baisser. Je peux le baisser. Ouais, mais tout à l'heure, on l'entendait pas, la Anna, sur son ordi. Attends, j'essaye. Ça va au niveau volume serveur, là, au niveau de puissance.
Encore un tout petit peu.
Tu veux que je baisse un peu?
Là, c'est un peu faible. Un tout petit peu.
Attends, putain. Ah oui, alors ça, c'est le problème des
souris.
Ouais, des souris sur les trucs en plastoc.
Ça marche pas?
Non, je prends un... Non, si, ça marche, mais il faut que je prenne un papier. Ouais, t'as un papier? Voilà, c'est parfait. On va mettre juste un papier. Parce que moi, tu vois, je suis pas très à l'aise avec les pads. Les jeunes, ils adorent ça, mais moi, les cheveux.
Voilà, c'est bien.
Voilà, comme ça.
Après, sur le Zoom, j'ai l'impression qu'on.
Un, deux, tu m'entends bien? C'est bon, le son est OK là? Bah, c'est pas mal.
J'ai l'impression que la musique, par la salle, qui le capte.
C'est saturé encore là, le micro? 1, 2, 1, 2, 1, 2.
Le son est trop fort?
Ça va, c'est
Le son est saturé ou le son est bon?
un peu saturé, mais je pense que c'est le mieux.
Alors, on peut reculer un peu le micro si tu veux. Là, c'est mieux là?
Ouais, un petit peu moins.
C'est un peu moins saturé? Là, là, je suis à 60 cm du micro là.
Ok, bah, c'est pas trop mal. Par contre,
là,
il y a le moyen de micro et de diffuser le son.
Par contre, on t'entend pas bien, on t'entend très très haché là.
Ah oui, non, mais ça, c'est lié à la connexion.
Ah, d'accord.
Non, ce que je disais, c'est que le son, il sortait pas, parce qu'il va avoir des extraits diffusés là, du coup.
Ouais, il y a des petits sons, tu les as pas entendus?
Ici, mais j'ai l'impression de les avoir pas entendus en direct depuis Zoom, mais plutôt par le micro.
Ah, ouais, par la sono quelque part?
Ouais.
Attends, je t'en balance un si tu veux. Est-ce que je peux balancer d'ici? Je sais pas.
Juste pour voir. J'ai l'impression que j'entends par la sono, hein, que j'entends par la sono.
Ouais, ça risque de repasser par les micros, ouais, c'est possible. Ouais, c'est possible, ouais. Ou alors tu as peut-être un mélange des deux, quoi.
Ouais.
Si tu baisses un peu là, ça fait quoi?
Ah non, c'est ultra saturé, c'est autant saturé que les micros. Du coup.
C'est pas saturé, ça va?
Non, c'est autant saturé que les micros. Du coup,
Autant saturé.
Ah ouais, d'accord.
C'est pour ça qu'il faut baisser un peu le niveau qui sort de l'ordi, parce que ça boucle entre les micros.
Oui, là, il faudrait couper le micro le temps, vraiment, c'est pas super pratique, quoi.
Ouais.
Il y a un bouton.
Ah oui, on peut.
Le mieux, c'est peut-être ça.
Ah oui, on va couper le micro pour voir si. Est-ce que c'était mieux là quand j'ai coupé le micro pour Est-ce qu'on entendait la musique?
Il y a eu un son de... Ouais, j'ai entendu un son même avec le micro. Mais c'était pas saturé.
C'était pas saturé quand j'ai coupé le micro? Bon, bah, il faut couper le micro quand il passe de la musique.
Quand il y a un petit peu de son, il n'y a pas beaucoup. Hein.
On s'en sort pas, quoi.
Il n'y a pas beaucoup de son.
Parce que...
C'est ici, là. Donc, si je passe de son... Ouais, ok.
T'imagines, elle est
Bon, si c'est que ça va. Hein. Si c'est que ça va. Parce que moi, j'ai pas énormément. Hein. J'ai juste des petits extraits sonores. J'ai pas mis. Vu qu'on a qu'un quart d'heure, j'ai pas mis.
Ouais, mais bon, si c'était que le Zoom, pas tellement que ça sur Zoom.
Bah, de toute façon, tout le monde, ça passe.
C'est pas le métrage.
Mais du coup, par contre, ça sature toujours un peu.
Mais même quand je me coupe le micro?
Ah non, quand c'est les sons qui viennent de l'ordinateur, j'ai l'impression que ça n'a pas de problème. Ça passe en micro. Ça passe dans la son.
Ah ouais, mais c'est bien.
Use that behind the scenes. How to code. Oh, yeah. Yeah.
Cher voisin.
On est tous les voisins, presque.
Ah ouais, c'est vrai que... On va y aller, chef.
Donc le retard ne sera pas décompté.
Ah, t'es sympa. T'es un pote.
Moi, je parle un peu. Là-bas, c'est maintenant. Oui, tu veux. Le rouge, là.
Voilà, c'est ça.
On commence? Bonjour tout le monde. Donc c'est moi qui vais animer cette session. J'espère qu'on va s'en sortir parce qu'il y a aussi deux qui sont sur Zoom, si j'ai bien compris. Et Oops, pardon. Sorry. I'm so happy to speak French sometime. So, hi everyone. We're starting the So I was saying I'm hoping it's going to be fine. And the first one is Bertrand Petit, who doesn't come from the Netherlands.
No.
Like yeah, okay. So it's a mistake on the program. I think it's from Nice in France, and is going to talk about music notation using reactive synchronous programming. So you have 15 minutes.
Thank you very much. Hello everyone. I will apologize for my English. I am a French native speaker, so I'm not coming from the Netherlands. I'm coming from very not so far from Nice, which is 2 hours by train from here. So I have the chance to share the sun with my friend of Marseille and so on. So I am from INRIA. INRIA is the main French laboratory. Okay, it depends. Si c'est trop près, je crois que ça sature. Ouais. INRIA is the main French laboratory concerning computer science. Probably you heard about it. It has a close relationship with IRCAM. Jean can can explain that also. And I have both hats. I am a computer scientist and also musician. I will speak as a computer scientist today, not so much about music, only my music. So let's start. The title is Music Notation Using Reactive Synchronous Programming, which is a bit way probably for you if you're not a computer scientist. So I prefer to use maybe the title, How to Write Reactive Scores. I think you are more familiar with that according to what I saw this morning. So, okay, let's go. I have 4 parts in my presentation. Okay, a short introduction because I think it's not necessary. So, what is music notation? Okay, you know better than me what it is. According to what we saw this morning, it could be, of course, a written score in different forms. It can also be different computer tools. Okay, I put there only some of them. I should have put, for example, what we saw this morning concerning virtual reality. Okay, it means that it's much more than only writing on a paper. Music notation so means, of course, programming of sequences. Historically, a score is something as a sequence, and you read according to the time, and you go somewhere, and you can go back, and so on and so on. So this is the first, let's say, historically, the first goal of a score. Now is much more than this. Of course, and you know better that means that, okay, it's also a way to control music in real time and the behavior of music in real time. So, what is a reactive score? For me, a reactive score is a musical score that could have different behavior according to what's happening, according on events. What is an event? Not necessarily an easy thing to explain. As an example, it could be a clock somewhere, something telling you, okay, you have to go there, okay, the time is passing on. It could be any message coming from a sensor, for example. You have a sensor who count the number of people, the temperature, the humidity of somewhere, what you want. It could be also an action on the web interface by someone in the audience. Okay, it's an event. If you ask, you give the possibility to people to act on the to the score according to Markov chain or what you want. It could be even something happening inside the score. If you have, for example, a random process acting on the score and something happen according to this process, acting a specific piece of music or part of music, it can generate an event inside the score. So you see, it's quite a broad definition of what could be an event. Now, the difficulty is that manipulating event is something very complicated. I suppose that some of you are working with tools, let's say like Ableton Live or Betwixt Studio or Max MSP, and you know that it's very difficult to manipulate a lot of events in the same time. Because these tools are not done for that. The common tools we are using are not designed for that. So I focus specifically on this problem of managing complex events inside the score. So my proposal and my field of research is to find first a method and to develop a tool for creating this kind of scores based on, let's say, a basic principle. One of the basic principles is to use the concept of clips. I use both terms, clips and pattern, more or less in the same way. Clips is maybe more popular because it's very well known by the people who are using Ableton Live, for example, the clip in Ableton Live. A pattern is something a little bit more wide. It could be, of course, a clip in the sense of Ableton, but it could be also part of digital audio workstation. So, for example, you have this could be a sound pattern, for example. So, short phrase could be also a short phrase of bass, something with percussion, for example, if you want. Could be something more techno, Berlin. It could be also a phrase in a jazz lick, for example. And the representation could be, as you see, a MIDI. It could be a score. It could be even a sound. So this is the basic element I decided to take into account. This is a personal choice. It's not necessarily what you will do, but I think it's a way to approach the question. So I am addressing the process of composing the music. I will not enter too much into the technical details. I'll try to have a point of view from the composer, let's say. So the first step for the composer is to design these clips. The second step for the composer is to define group of clips or tank of clips. You will see a little bit later why. But okay, a group can be, as you say, a group of some patterns, of some clips, either on different instruments. Here I use the representation of Bitwig. So you have the instrument, or like Ableton, you have the instrument on tracks, and you have the clips on the line. So it could be, okay, a group of different patterns on different instruments. It could be a group of manipulate either the clip by themselves, isolated, or by groups. You will see why, because, okay, the idea is to give this group access to this group for different processes and so on. So once you do that, once you have done that, what the composer will do is to write the score by itself. So for that, we use a specific graphical interface. Maybe people from you know Scratch from Google, the interface which is used for the kids in order to learn how to program. So I use the same interface because it's quite convenient. So the composer can describe the score with that, using a specific, of course, a specific semantics, which is the semantics I will explain a little bit after that, which is due to this language which is dedicated to the manipulation of events. So the reactive score can, as written here, directly play the script. So you can ask, okay, play this one at this moment if you want. It can less event or play or access to not only to a specific pattern, but to a group of patterns. For example, if you want to give access to a random process to different patterns at a certain period of the score, you can tell to the score, okay, give access to the process to this group of patterns, and the process will choose among this pattern the one you want to place. Or it could be a random process, it could be you. Complex event according to different statements. I have some example here of different statements you can use. Could be long to explain all these statements. There are not so many. I think the basic grammar of the language you're using is only 20 statements. Not as difficult as learn compared to Max MSP, where you have hundreds of primitives, for example. In this case, you don't have so much primitive to learn, but the philosophy is a bit difficult. The programming came from a specific family of languages, which was developed in the 80s by INRIA, in part, an école des mines, which are called the reactive synchronous languages, which are dedicated at the beginning for manipulating what we call automaton. Automaton is not exactly the word we are using in the common language, which means little clocks or this kind of things. It's something which is a complex problem for people dealing with, let's say, power plant, airplanes, the transportation, when you have very complex events to manage in real time and in a very efficient way, a very stable way. So a family of language was developed. Among these, one which is called Esterel, in reference to the mountain close to here. And this language has a long story, a long industrial story, and was redeveloped by INRIA recently over JavaScript in order to work in a web environment. So the next slide, very quickly, is to show an example of how it works. I will not enter into the programming part of the game because it's a bit complicated, but just to give you a flavor of what's happening when you run the system. So here it's a simple use of the system for only to play a sequence, okay, which is not the most interesting, maybe the most complicated thing, but okay, it's just an example. So the first thing you have a clock event which is generated, and you see a little link here. So it activated the reactive score. The reactive score decided to put, okay, so choose from the reactive score to put two patterns on an instrument. The instruments are, okay, it's like a representation you have in Ableton or this way. An instrument is the column, for example. So you have two clips in this. So the system plays the first one. When the first one is played, it plays the second one. So the idea is here to show you that if the system asks for several patterns for the same instrument at the same time, they are not played all together at the same time. You have something waiting a queuing system in order to avoid to recover, to have the pattern one on the other. So, for example, you can receive an event for a game through an OSC command. Okay, it's reactive. It reacts, so it asks for. Okay, simple. And then the system can tell to the score that, okay, I just played this event, and when you receive, for example, a signal telling you play this event, this pattern 2, 3, and 5, the score tell, okay, now you prepare the playing of the pattern 1, and then you play the pattern 1. Okay, you understand more or less clearly the global picture. I think it's not necessarily very complex, but okay, it's not so simple anyway. So the same thing, but not using direct command, but using an external random process which will generate pattern activation. So in this case, okay, we start with the clock. The clock make the reactive score to react, and in this case, okay, we get 3 patterns available. It means as a composer, I decided to put at this time, okay, you can use these 3 patterns. The random engine act and choose two of them. Okay, we choose 2 of them, and we put this on the instrument, and we play the 2 one after the other. So we have another event coming from a game. Okay, the system reacts. So we have 2 more patterns in the available patterns. The random engine act in this case. Okay, choose 1. Okay, choose 1, pattern 5 and pattern 2. Okay, so they are played all together, and okay, and the system. In this case, quite simple. We had only two family of events: one clock and something coming from a game. Now you can have 2 events in parallel. You can have 2 events combining. If I have one, I don't want to have the other. You can have all these complex combinations which are very difficult to express. And with the system I'm using, is, let's say, very close to the way you express it when you speak. So I think it's much easier. And moreover, the system allows you you are sure that it will work exactly as you described. The system is based on mathematical formalism, and the system can prove that it works, which is not so common in the programming world today. There are very few languages we have formal semantic, which is complete. So it's more. So you can make complex scores. This is kind of music generated by the system using short patterns with a random process. So, okay, just to give you an idea of how it could sound. Now, in this case, it's close to jazz music, and jazz music is quite well adapted because it's based, basically, as we saw with Raphael and Vieira yesterday, it's based on licks, and basically licks are very close to pattern, what I call pattern. Okay. I will stop this one. Okay, well, the end. So the idea is that the method is to allow to design complex music piece that today are not possible to manage using standard tools. I did some comparison. I think in the paper I wrote for the conference, I made comparison using, in Ableton, you have, if people are familiar with that, you have the follow action in Ableton, which allows you to sequence or to build sequence of pattern, which is a very good solution, thanks to thanks to Ableton. But if you want to do complex things, it's a nightmare. it's a nightmare to make it, and it's a nightmare to maintain it, because once you have done it, you don't know. If you want to modify, it's impossible to know where you are. In my system, it's quite easy because you just have to move some statement, and you can change completely the behavior of the piece without too much difficulty. Alors, an important point, and the platform is based on web technology, so it's very important because it means that you can interface it with what you want today. So I have two different platforms, and one on Node.js, and one on a specific solution from MISRA, which is called RODRIGUES. And okay, it's easy to have MIDI interface. I use it, for example, I control Ableton using MIDI, for example. I control Between using USC. I interfaces a lot of sensors from Z interface, for example, if you know it, using USC. I have, of course, developed some interfaces for the audience using standard HTML. In 2017, for concert in Nice, using web interface in the audience, and okay, it works. It works okay. It's not so very difficult to implement. So, so if you need more information, of course, you are welcome. I have some demo. I think I show it in the picture, and you have it in the paper. So if you want to use it generated by this kind of system. And of course, you can contact me when you want at inria.fr. Jean, up to you.
Thank you. Okay. Any questions? Super fun.
Is it possible to manipulate those statements like in real time, that I change my statement, I move it further, or I just strip out some part of it? Will it change, or I need to recompile the script in order to?
Yes, you need to recompile. Yeah. It's not a live coding solution. Yes, because you know an automaton is a complex system, so you have to rebuild it when you modify. And you can have mistakes if you don't use a good statement.
But the way you said that you were with the users web interface in 2017, how did they? I mean, they sent the request to some address on the server, and you were.
The idea was very simple. We have access. We have a local network with a local server, and I give an URL, and the other specific web page in which you can have action on the music. So it is specific, for example, for this concert. But what a typical scenario is, for example, to add something as a game and give to the people access to a list of patterns and tell them, okay, build me a sentence of harmonic sequence, for example. And if the guy chooses the good pattern with the good harmonic sequence, which is quite close to what you explained this morning, they get a note, and he can have on the screen, okay, and now wins, they choose the good sequence, but you don't, and you have a score, but you can imagine what you want. It's quite open at this level.
You have to speak loud and reach this microphone.
You talked a little bit about your formal semantics. I'm wondering, do you express it in some specific existing formal model, or you write your own?
No. The language by itself, STRL, was built in the 18 by Gerard Berry. Maybe you heard about Gerard Berry.
Yeah, so this is based on STRL?
Exactly. The semantic is the semantic of STRL. So, okay, I think it has something as 20 PhD on this language. And it was used by SCAD, which is a huge platform for real-time embedded solution for airplanes and so on.
I thought that STRL was closed, right? Or can you use it now, like in language?
Alors, STRL by itself, the language was developed, the STRL compiler is not, I think the old one is open source, the new one is not, because it's proprietary. But HipHop, the language I am using by INRIA, is a new implementation of STRL. So this one is open source. You can use it if you want. Yes, sir.
where are the limits in terms of functionality of the language? For instance, can I easily define a user-defined function?
Okay. Yes, you're right. You
how complex can
exactly.
Because it looks nice for more simple.
No, you're right. This. If you heard, we spoke about STL, it has the same modularity. You can have module, call module, and so on and so on and so on. And you have a specific function which is very important is that you have parallel. Parallelism is fully integrated into the language. So you can have module and put as much as you want module in parallel, just with one statement, which is, I think, one of there is no so many language which allows parallelism natively into the language with the formal semantics, and it works. So it could be very, very complex, as you want.
Thanks.
Yeah.
One follow-up question, but so the representation of the language is always in this sketch.
No, alors. Generally, this is a text programming language, and yes, but I thought that for most of the composer, it's easier to have this kind of syntax because it's more abstract that writing. The complex, maybe not very complex, but you have to write. And most of the composer now I use to Max MSP and this kind of interfaces. So I try to find a match between something which is easy and which is close to the capability of the language. But if you use the text, the language in its text forms, of course, it's more powerful because you can integrate natively JavaScript into the hip-hop code, which is not so simple using graphical representation.
Thanks.
Yes, sir.
Last question from Ray.
Yes, so it seems really handy to write the dramaturgy of the piece.
Yes.
So this question of the composer, can you use it at the form level of let's say long-term composition with some variations and repetitions?
I think you touched a good point. I think this is basic of this tool. This is a tool dedicated to forms. You see, I did not focus on synthesis, on sounds. I rely on other tools for that. And as you mentioned, I focus on the structure. And this is a language dedicated to the structure and basically to the form. And you can manipulate the form in a very easy way because you can have a BBA form, for example. But if you want to change, you just have to move one block and put another block, and it's very easy to manage. So it's basically, you are completely right. It's for manipulating structure more than sound. Sandeep.
I have a question about the output. You just showed us audio output.
Yeah.
So I assume that you can also have graphics as output, or is this not possible?
Concerning the connection. Yes. Concerning the connection with other graphical representation, what I did, for example, I interface it with Unreal Engine, which is a game like Unity, a gaming platform, and I discuss with Unreal Engine using OSC commands, and I control the graphical card of Unreal Engine. Another experiment I did is I'm using processing, the tool from the MIT, and I can discuss with that using the same way, using OSC, and I control the evolution of processing using the system. As you can receive command and send, of course, also events, it's a question of interconnection. But the system in itself has no specific graphical capability. It's external to the system. The system, as mentioned, is more concentrating on the structure of the piece and the organization of the piece and of the events.
Okay, I think we need to move on. Thanks a lot.
Thanks to you. Thank you very much.
So now is when we put Zoom on. So, Hello.
Hello, good morning.
Good morning. So our next speaker is Chandan MISRA. I'm just being told that he's not from Netherlands either. So you're in India, right?
Right.
So because we have a little thing in the program here, and everybody seems to be from the Netherlands. So hi, Chandan. Nice to have you here.
Thank you.
I will let you speak in just a minute. I'm just reading the title of your paper called SangeetTEX. I don't know if I'm pronouncing right. LaTeX engine for transcribing and rendering Indic music. So I hope you can hear me well.
Okay.
It's to you now.
Shall I share my screen?
Yes, please.
So I cannot share my screen. It's saying that you cannot start screen share while the other participant is sharing.
I think we had the same before, no? Can you try again, maybe?
Sure. No,
What
it's
does
still.
What do you get?
Giving me the same message.
Someone else is sharing the screen? Sounds like the same we had before, no? At the other session.
It's okay. For us, it's okay.
While the other participant is sharing.
Do you need to enable this?
Just need to check the apps. Autorisé. Mais tout est autorisé. Ça a fonctionné.
Just nice.
Les autres vont fonctionner très bien avec ça.
Ouais, mais lui, il avait la même chose.
Non. C'est là, c'est à lui.
Shall I log out and log in again? Oh, now it is okay. Now it is okay. It's coming. Now it is coming.
Now it's coming. What did you change? Seems to be coming here. Yes, we see you. Great.
Okay, so shall I start?
Yes, go ahead.
Okay, thank you. So good morning to all of you. I'm Chandan MISRA from Univeristy, Bhubaneswar, India. I'm presenting my paper titled SangeetTEX, a LaTeX engine for transcribing and rendering Indic music. So notation system is the building block of a particular genre of music, which aids in reading, composing, and performing music in a structured manner. Staff notation is the standard music notation for traditional Western classical music. Although Indian classical music notation system for aiding the learning as well as performing the traditional art form. So Pandit Vishnu Narayan Vadkhande and Pandit Vishnu Digambar Paluskar was the first to create a notation system for North Indian classical music or Hindustani Sangeet, termed as the Vadkhande and Paluskar notation systems respectively. Rabindranath Tagore, a poet and Nobel laureate, gave birth to a unique kind of music genre called Rabindra Sangeet, also proposed a new notation system, Akarmatrik notation system, which was used to notate all of his more than 2000 songs. So there are other prominent notation system present in India. Some of them are Dandomatrik notation system and Sargam for South Indian classical music or Carnatic Sangeet. So since it is very important to make Indic music on the computer in terms of music education and practice, the very first step towards practicing the art in a more Indic environment. And so one of the starting points of for creating such system is to provide a tool to properly render the music sheet on a piece of paper. So there is an example called Swarshala from Swar Systems, which is a prominent Indic music software that allows practice, compose, and learn both Hindustani and Carnatic Sangeet. However, it now, so the system requires a mathematical realization of the sheet architecture in a computer and respective musical fonts for transcription. So one of the attempts was to render Tagore compositions in a computer that leads to a mathematical framework, Sorolipi. So that tries to make a unification of various Indic music representation while extracting common features of different notation systems and language script to make a general notation system. So, however, such a framework, when actually implemented, does not generate expected results. Okay. Due to the rendering challenges posed by certain musical symbols. Say, for example, here Mir symbol of Akarmatrik notation system and these vertical lines in Bhatkhande and Paluska notation system. So it is not easy to place music symbols above and below other symbols, which is why new notations are developed to curb the need for digitization of music sheets. So while these systems are quite capable of rendering, storing, and playing back music, publishable quality rendition of music sheets is too hard to achieve, and therefore it actually diminishes the very objective of creating the music sheet in the first place. So in this paper, we try to develop a rendering engine, SangeetTEX, based on LaTeX document preparation tool that specifically allows music software developers to create print quality music sheet implementing the grammar of Indian classical music. So SangeetTEX is built upon a well-established musical framework, which is called Sorolipi, has been created to encode, arrange, display, and render Indic music symbols on a computer. So the framework can arguably support all major Indic notation systems active presently in India. The framework can be visualized as a collection of 2D matrices of heterogeneous dimensions, where each 2D matrix corresponds to a single line of composition. Each such matrix consists of cells at each intersection of all the rows and columns of the matrix. So these cells serve as the container of the music symbols. Now the row and column model define the number of and align of the rows and columns of each 2D matrix in the model. While row model takes only the lines of the composition as the input, the column model calculates the number of columns using 3 parameters: tal, the avartan, and the number of, that is the number of cycles, and the position of each music symbol in each 2D matrix or line. So we have maintained the same input parameters while designing SangeetTEX. So since we are interested in creating a new document format, that is a music sheet for sport transcription and not in adding more functionalities to an existing type of document, a class rather than a package have been considered a better choice for our project. So 2 classes of symbols, the scores and the lyrics, are rendered using 2 different fonts. For lyrics, a Unicode Bangla font named Bangla has been used, and the scores use a custom font named Sorobitan, which was designed particularly to be used for writing scores for Rabindra Sangeet music sheet. Or Lua LaTeX input and font aware engine. So the structure of the music sheet is implemented in a single class file, which is called Sangeet class file, and is primarily made up of two commands, a score line and score lyric line. So score line and score lyric line correspond to creating a score line with, without, and with a lyric respectively. The score line command takes three parameters: the name of the tal, the number of avartan, and the note sequence to form a single line of score. The score lyric line command has an extra parameter, the lyric syllables, to be added beneath every note in the score line, along with the above mentioned parameters. So the primary objective of the score line command is to calculate the number of cells required to accommodate the music symbols and their respective positions on that particular line. So the computation on the number of columns requires two input parameters, tal and avartan. These parameters have been given in both the classes score line and score and lyric line. However, the tal name does not contribute to the actual calculation and therefore require other tal related parameters like matra or measures total bit count of a particular tal. Another important symbol it is required to know the positions of the start and the end notes. To annotate the start and finish of the mean in any line of composition, we place a backtick as given in the line, a character just before the corresponding note. Once we get the start and end characters, we can draw the mean from the start to the end. The user can then place the musical symbols according to the notation presented at using this table. So we use TIX library to render the music sheet, and once the position of the music symbols have been evaluated, it is easy to place them using TIX. So each line of the music piece or 2D matrix is rendered with a separate, and each cell of such a matrix is realized by a TIX node. A TIX node is a named placeholder which can contain text inside it. The name of the node it uniquely identifies it in a figure. To render a single line, we create the number of columns required square TIX node and set the name of the node with positions 1 to the number of columns. Now, since we already have the positions of various symbols, we insert the symbols at text into respective nodes. For the rendition of the mirror symbol, we use the draw tool of TIX and create and two control points that determine how curved it is. We place the first two endpoints at the bottom midpoint of the start and end node of the mirror. However, in our case, the curve operation is accomplished using angles instead of control points. We provide angles at which the curve should leave the start point and reach the target point. Moreover, we create a cycle by drawing another curve just above the already drawn curve that reaches the start point from the end point. At last, we fill the area created with color so that it looks exactly the same as me. So we try to show snippets of the LaTeX code and the corresponding rendition of the music sheet. We will also provide the metadata of the song so that the reader can validate the transcription as required. We give several renditions of the composition with some of the prominent tals of Indian classical music. The simplicity of the engine lies in the fact that it only requires the name of the tal and number of avartan of the composition, and everything else has been taken care of by the rendering engine. The second figure demonstrates the rendition of the variations of the mid symbol in different contexts and therefore proved to be a better rendition engine than published music sheet. So in this work, we developed a music sheet rendering engine, SangeetTEX, akarmatric notation system. SangeetTEX is implemented on the theoretical 2D matrix model Sorolity with the instructions to structure rows and columns of the every line of the composition. We give details of the class file along with the commands that are responsible for the rendition of a score, lyric, and variations of score in the composition. We give special emphasis on the rendition of the mid symbol, since it is one of the primary reasons to adopt such a document preparation tool to prepare print quality music. So the engine is in its initial stage. So we still need to include many more features of the music sheet and also include other notation systems as well. Therefore, anybody interested to work in these, kindly let me know. I am happy to collaborate. Thank you.
Thanks a lot. Is there any question in the room? Yeah, a lot of questions. Maybe Sandeep first.
Sandeep was first, but I would like to go second. Okay. Hi, Chandan MISRA. I'm Sandeep BHAGWATI. And thank you for your presentation. It was great. I think it's a big improvement of the Svarality system that we had seen and Terri. Still, the rendition of a mean is still very abstract in this notation. We don't really know how the mean goes, which exact shape it has, and so on. And I wonder if you are aware of the system of Ramesh Vinayakam, who was presenting at China 2019 in Melbourne, who had introduced the system of the Gamak box. Do you know about this system?
No.
And okay, so I would connect the two of you because I think his system of Gamak box could actually be a kind of a font.
Sure.
And could be a really interesting expansion in order to notate exactly means and gammakas, which are absent in all the other notation systems.
Right.
And it would be really wonderful if that could be combined. Thank you.
Sure, absolutely. Thanks for the suggestion. I think I remember I met you in Cambridge 2016, and we have a chat there regarding the framework of my system. So we are in the process of a complete ecosystem where our music notation can be developed using a completely Indic environment. The notations, the language script, and everything else is not in the staff notation. So we are in a very rudimentary stage. So if we can connect with any other
Hello, Chandan. My name is Giovanni. I'm the co-author of an environment which allows you to translate different notations, also non-standard notations, into other representations. So I really appreciated your presentation because it would constitute an interesting use case for the environment. So the question is, have you considered also yourself to create a translation layer for your software that translates the notation, the Indian music notation into European standard European notation? Is this like a figure that this is not quite as simple as we might think, because one symbol here also may correspond to a series of notes, not just one.
Yes. So one of the difficulty of converting an Indian notation to a staff notation is that there is a difference. So we have unequal peak patterns in Indic notations, but that's absolutely not there in staff notation. We have equal peak patterns just in staff notation. So there's difficulty, but we can. So we have one-to-one mapping from the Indian notation to the Western staff notation. There are other problem that we can face is that the shrutis or microtones. So there are Indian genres where say for example, Rabindra Sangeet, Tagore song, we have microtones available between two notes, and it's not only one microtone available. There are 22 microtones in an octave, right? So I don't know how we can map those microtones from Indic music notation system to staff notation, but it's very possible. Yes.
It would be interesting to see maybe something written by hand, a translation between these symbols in Western Standard Notation or staff notation.
Yes, that's very interesting.
It would be nice so if we could also stay in touch.
So actually, we are in the process of preliminary work where we are actually having optical character recognition from the scanned music sheet, and it's automatic. Easily converted to the staff notation. That can be possible.
Okay, thanks a lot. I think we have to move on. We're a little bit late already.
Thank you.
So now we switch speaker on Zoom again. No? Ah.
I figured that right there. Also, I figured that.
N'hésitez pas à avoir la conversation.
Hello. Bonjour.
Ah,
Tout le monde.
hello? Can you hear me?
I have a problem to open my camera.
Everything okay?
Moment, please.
Hello.
Hello?
Okay, I hope everything is doing fine now.
Hello, yeah, can you hear me?
Oh, so yes, very good. So sorry
This is
for the little problem here setting the system. Okay.
We've been, okay.
I
We're getting good. Transmission était là. What's this? What's Stella?
Screen.
Screen, okay. Okay, there, I think we see you and we see your screen.
I'm sharing my screen, but
Yeah, it works, I think. No, it's
okay,
kind of
it's
works.
fine
Yes,
now?
we see. It works. Yes, we see. Don't touch anything.
Bonjour tout le monde.
Hello, Vander.
I'm Giovanni Vieira from Brazil.
Okay.
I'm now in Recife, northeast from Brazil. I will talk about the textural composition in 3D environment through Swarm algorithm. This work is a partnership between me and Master Valber Rodrigues. And this presentation, you have two presenters, me and him. And in the specific time of the presentation, I would like to change my voice with him, if possible. So I would like to have Valber Rodrigues, his mic open to, if could be. I am very grateful in advance. So this work starts after we find that some specific behavior of the sound is different when we use some music basements like melody, rhythm, and harmony, and when you use only noises or not specific sound music. So the basement for this project is the projections of images in 3 dimensions, and music interactions in 8.1 surround, to have a human agent immersed in the D chamber to generate sound masses in real time. The musical approach is textural music. The man is, the agent is acting with digital swarm, with some flocking birds and improvisation. The swarm concept is a large number of homogeneous simple agents interact locally among themselves in the environment. This behavior in birds, for example, can be to bees or could be to fish, but for birds is to protect themselves from predators and so on. But when we see and start to see the body, the complete body, and that is our approach in this project. And you can ask for me, what moment do you find that this behavior of the swarm, for example, could be related to the sound? Are you be there soon? So in this concept of swarm, each particle represents a candidate solution for optimization problem. Why? Because the movement of each part can direct the other parts for one point. Then this is the basic of the concept in the swarm behavior. And this generates the concept of particle swarm optimization. That is a stochastic optimization approach modeled on the social behavior, body flocks. This concept is also used to telecommunication network optimization, graphic coloring, product application problem, clustering optimization, structural optimization, and so on. Here in this image, we can see the flock birds. We don't see anymore the particle, the bird alone. We see the flock, and you could use design of a bird, but it's not a design of a bird. This is a mass of birds. And we could find that this similar process can be found in another sensory, human sensor. And what would be sound mass? Sound mass is a concept associated with music of 20th and the 21st century. This is involved to textural music. and some researchers call them sound clouds too. And like the swarm, they induce a process of statistical evolution, similar with swarm, as I said before. Our mind is not able to create imagery. I will explain this point a little later. In different when using melody or traditional music-based methods. Here we have a score of the Georg-Ligeti atmosphere, and we can find some researcher like Francoli, Clendening, Bader, and so on, and another great researcher that perceive the next structures, pattern mechanical, and fractal behavior in this score. But the approach we could find this behavior from another point of view. The point of view that we use to see this behavior was based on the sensory cognitive perception. Well, when you listen to a drop of water falling on a surface, we can see and we can find the directions of the sound. But when we start to see the rain that are basically only a lot of drops of water, we lose completely the individual perception and start to perception the phenomenon like a bat. I use this word now. What this means? This means that we extrapolate the perception in a level that you can use not the same name like drop or a group of drop. We say rain because the extrapolation is so high that we change the name of the process. And this behavior, we could find that's not only particular for hearing or vision, because vision we have not only the swarm, for example, we have a mosaic stone and so on, colored stone, we can see another form. The tactile, we use you can perceive the fabric threads, but when you have a fabric, we can see anymore the fabric thread. Smell is the same, taste is the same, and so on. I would like now to give the voice to Master Valber Rodrigues to talk about the mathematical model. Could it be?
Okay. Thank you, Professor Wanda. Our objective here is to mimic the behavior of sound masses, adapting a mathematical model from the particle optimization algorithm to a 3D environment. So in general lines, the first step in our system is the sound capturing procedure. So a person records samples using a microphone, like clapping hands. And then these samples will be transported to the 3D environment using in the shape of a bird in the position, velocity, a visual field, and the swarm optimization function, the swarm functions, swarm forces. So the position encodes where the bird is located in the 3D environment. So he can move along with the other birds. The velocity is the physical quantity that will update the bird's position. This velocity is initialized randomly and will be updated during the simulation steps. The visual field is a simulation of the animal environment awareness, so he can see other birds. And finally, the last attribute are the swarm forces that will rule how the swarm will move through the simulation. Our first concept is that we would like to introduce is the bird visual field. The bird visual field defines how far the bird will how far the bird will look. Professor, if you could you please go back one slide, please? In the current position of the bird and has a radius. So each of the bird that is inside this radii is considered in its visual field. This is important in during the swarm algorithm due to awareness of its surroundings and the concept of the flock. If you have if a bird can see another bird, it will flocks toward him. So could you please next slide, please? So the flock is ruled by three main forces: the separation force, the cohesion force, and the alignment force. The separation force separates the birds that are too close to another one. So this is a individual force that will scatter birds that are too close to one another. The cohesion force, on the other hand, will agglutinate birds. However, this agglutination process is done by in its visual field. So when a bird sees a group of other birds, it will move towards the other group. However, without agglutinating very much. And the alignment force is the third force that will match the bird speed to the mean flock speed. So the bird will move together with the flock, aligning its speed, moving together with the flock, however, not too close. So next slide, please. With these three forces, we can update the velocity or the speed of the bird using the first equation. Basically, each force has a constant associated to it. So these constants are important to balance the scattering, the cohesion, and the alignment forces in order to avoid complete scattering of the flock, a complete agglutination, or a complete alignment between the birds. So these forces updates the velocity, time frame defined by the delta t in the second equation to update the bird's current position. So with this environment, our objective is to with this with this interpretation, our objective is to create a general optimization, a general algorithm that can work with multiple swarm behaviors. Next slide. Finally, the steps of the model of our system we can define in three main ones: the acquisition, the superposition, and the swarm behavior. The superposition step of the process is when multiple birds associated with multiple samples start to flocking together. These samples and these birds, they have an individual period of repetition. However, when they are close together, when they are grouped, they emerge a new pattern, a new grounded by the signal processing literature, where the sum of two sinusoidal periodic signals is also periodic. So when you create periodic sound samples, this new swarm of sounds will also be periodic. Next slide. This system we created using the Unit 3D engine. Our objective is that this, with this engine, we could create a multi-platform environment where you could either be using it in the by yourself in your computer with your phone, for example. However, our objective is that it is used as a complete 3D environment. So if you have multiple screens, of if you had a VR headset, this would be the optimal solution due to the immersion characteristics of the swarm. Next slide.
So, sorry to cut you, but we will need to go to the conclusions.
Professor Vander.
Okay. Could you come back to me, the video, please? Hello? Hello?
Yeah, we can hear you, Vanda.
Okay. So here we have the steps. The immersion in digital space, generations of digital birds, sound capture, interactions, and the overlay of the several birds, and the sound and visual results. Here, the implementation of the system is the computer using the Windows system. We use this. You develop the research in the Mix Unicamp Lab, Campinas, São Paulo. And here we have the projections in the screen. Then here is a 2D projection with the flock birds. We needed to improve the design. We have, instead of the ball, we have the birds in this position. Here's a simulation of the sound overlap. And here is the system without the agent, but we have here the sound and the behavior of the birds. Of course, it's not the birds yet, the balls. We need to improve the design. Conclusion, we expose the project to obtain tangible results from points of view, visual and the sound experience. We coded to generate the sound with percussion, clapping, whistling, and musical instruments like xylophone during this project. Experimenting grasp the ecological approach to birds for students of the secondary schools and the option to select some sound masks combining each other and to compose with the finality to compose a textural music. Analysis of this sound extrapolation results from the interactions of digital environment. There is a possibility of music sound installations to be present in the article's presentation. And this neuroscientific study of the agglomeration process of sound and image need more profound research. The study is currently in progress, but without publication, and look for partnership. That's all. Thank you very much. And I hope you enjoyed the presentation, the project. Thank you very much, and I'm open to questions.
And then we'll move on to the rest. Yes.
Thank you for your presentation. I was quite curious about the audio results. Is there opportunity to hear this online or possibly even work with you said you developed this in Unity. Do you plan to make that data or that file available in the future? Because I'd be curious to dive deeper into it.
Thank you very much.
Okay, can I answer the question? So we have some video results from interacting, and we will make the source code available at my GitHub. It's Valber GitHub at Valber MR. So if you I think the link is also present in the paper, but the results are the source code will be available at the Valber MR link GitHub.
Thanks.
Okay, thanks a lot. Sorry, we really need to move on. We are exactly on time to be 20 minutes late, but we started almost 15 late, so it's not so bad, all considered. Thanks a lot for being with us from Brazil, and I wish you a great end of the day. And without the transition, I leave the stage to Sandeep and Terri for the second keynote of the conference.
Hi, everybody. We're keenly aware that you're running on an increasingly empty stomach. So we will try to be as entertaining as we can. We'll start maybe with a little story, an old Sufi story. A sultan once had difficulties choosing between two seemingly equally competent contenders for the role of his chief minister, his vizier. He resolved to settle this question by a test of their organizational and aesthetical qualities. He asked both of them to organize a tenor conference. No, a feast. Both feasts were supposed to take place in the same location, a royal garden, within the space of 1 month. At the end of the second feast, the winner would be declared vizier. The court was giddy with anticipation. The selected guests arrived for the first event. They were charmed. The garden was transformed into a true wonderland of light and fragrant smells. The most enchanting music was played by beautiful performers everywhere. The dishes were exquisite and their order was wonderfully composed. All servers and performers were dressed with the most beautiful costumes. The poetry recitations were evocative and wistful, and the jokes and the stories told were chosen with consummate taste. Many guests who saw the Sultan enjoy himself royally thought that such a feast could not be surpassed. They were sure of the winner and commiserated with the other candidate who had to follow up this grandiose performance. The next month, the same guests and the Sultan again descended on the royal garden, and imagine their surprise when they were grouped. The dishes and the dances, the jokes and the costumes, all were almost true imitations of their counterparts last month. After some initial irritation, the guests relaxed and again enjoyed themselves royally, were seduced by the pleasures of the feast. Then the moment of decision came. It seemed obvious to all that the first contender had won hands down. Had he not been the more original, the other a mere copycat, even if his feast was really enjoyable. To everyone's surprise, the Sultan declared the second contender to be the winner. Our first host, he said, was imaginative, tasteful, and resourceful. He created a very special moment in time for us. But the second did the almost impossible. He has brought back a precious moment in time that had already been snatched from us. He made us relive a magical, unique experience. He conquered time itself. To me, this story is the story of the musical score. A magical act of musicking preserved to be reanimated, a precious moment once more made available to us mere mortals who swim in the flow of time. Scores help memories to become the present. And sometimes we have dwelled on portents of the future so much that our scores will turn into pre-memories of the future. They whisper to us knowingly
Still you.
So this was the story. This keynote is half a report of what happened and half wishful thinking. Let us start with the report part, then we can dream later. The Tenor Network was a development arising from the Tenor Conference series. It was the expression of a nascent community, the first of hopefully many more attempts to create stronger bonds between the largely individualist and widely dispersed research groups that had formed at various universities in France, Australia, UK, Germany, US, and Canada. It was intended to provide some seed funding to create a larger network. One thing I noticed early on about this Tenor community was the absence of ideological strife. Almost every avant-garde musical movement over the course of the 20th century had been a battleground of different schools, of different technologies and politics. Tenor, I thought, was largely agnostic in this regard. It welcomed whatever someone thought would qualify as a notation technology. Maybe this holistic attitude was due to the non-aesthetic word technology in the title. Maybe it was due to our wonderful nature, but also maybe it was due to the fact that the general public generally does not care or feel qualified to comment on what kind of scores musicians use to produce this music. So whatever the reason, I felt very much at home in such an environment and wanted to support it by writing a successful networking grant application to the Social Sciences and Humanities Research Council. Roped in Terri, whom I had worked with before, to help me to write this complex grant. And she has been the coordinator and the main researcher for the Tenor Network over the last 3-4 years. With the general atmosphere of openness and conviviality that has always been remarkable at Tenor conferences, it soon became evident to us that certain tendencies seemed unnecessarily focused within the Tenor community. A narrow understanding of technologies as digital technologies, for example, the focus on notations that would benefit experimental tendencies within mostly Eurological music, and even if here and there we had some Indic or other traditions that came up. Even though it seems evident that introducing new technologies into an interface between musicians profoundly questions the nature of what a score is or could be, and what social and political realities this stands for, and what it could become, such questions were rarely discussed and hardly ever examined in depth. Yet it was clear to us that sticking to this friendly nonchalance about the aesthetic and cultural consequences of what we were doing would not help with the main purpose of the tenor network, namely to widen the focus of what notation technologies are, and most importantly, where and how they are practiced. If we just had gone to look for other labs that had similar focus on digital technology and Western style musicking, we would have repeated a cardinal mistake of the post-war avant-garde movement in music. Clubs worldwide. And in this case, it would have been supporters and fan clubs of the latest Digitech ideas, and not to look for actual knowledge about the diverse and largely wild world of notation technologies that existed.
From the beginning, as the Tenor Network's coordinators, we were curious and concerned about questions of representation. What did the current makeup of the group actually represent? Did this reflect institutional and academic network demographics, geography, and aesthetics? Or was there something particular to the subject and community around technologies of notation and representation? There was, right from the first meeting at the end of the Tenor Conference in Montreal, obvious areas of lack. There were hardly any women or non-binary people, and hardly any racialized people or scholars of ethnicized music. The same was true of the tenor conferences themselves, where the latter were always represented by 1 or 2 papers each time. The issue isn't straightforward. For the Montreal conference, there were quite a few women accepted, but they did not show up. This indicated that there must be a barrier to their attendance, other than the quality of their research. Indeed, the network was able to support the creation of a special fund to help cover the formerly prohibitive travel and child affiliation. Right from the beginning, there was unanimous support towards a survey or map of the tenor-related activities internationally. The survey project got off the ground with the network members contributing the names of institutions and scholars busy with tenor-related activities. This visualized the Eurocentricity even more dramatically, and so we thought to remedy the situation by hiring a research assistant out of Monash University to find tenor-related scholars or institutions in Southeast Asia. The results were underwhelming. It seemed nigh impossible to assist this kind of research with remote resources available in English or on the internet. We did not believe there was nothing to discover, but our method was unsuccessful.
Meanwhile, we organized one panel to help shift the statistics and conversation at tenor conferences. Notations beyond Eurological traditions at the Melbourne Tenor Conference brought together racialized and women scholars to discuss their own practice. We organized another panel at the German Society for Music Theory entitled Notation Technologies on New Score Interfaces for Live Musicking, with what we consider the healthy diversity to represent tenor. Half were women and racialized people. One was discussing popular music, and some were founding tenor conference members. It is important to note that, like the funding for all pop musicians had their travel costs covered and were offered a small honorarium. That's a very important, that we consider that a very important factor, that if you're not affiliated to your university, you need honorarium and travel.
With the limited success of our research project, the financial realities of bringing together such panels, and the limitations imposed by the pandemic, I proposed a different kind of survey project, one that had no pretense of being comprehensive, but that would start a conversation on scores with women, racialized, non-European, indigenous, and otherwise unrepresented groups within tenor. I also consulted with a small number of tenor acolytes who wished to contribute to the brainstorming on such a project. After conducting and transcribing over 20 interviews, I felt tenor was no closer to making any kind of survey. Maybe some definitions themselves needed to be expanded.
Udaditya Chattopadhyay, an Indian sound artist and sound scholar, his focus lies on listening attitudes in different cultures. In a conversation, he remarked on the fact that sound art festivals and academic sound art discourses are almost exclusively dominated by white Euro-American-centric practitioners and subject matters, even though the latest technologies of sound recording have generated a huge boom in practitioners of this sound art everywhere in the global south. He said, if no one writes about it, if no one will notice it, that it's happening, and no one will thus invite and discuss these sound artists. Hence the fact that we had so far found very few examples of researchers up the wrong tree.
When our survey project failed to put a pin anywhere in Japan, I thought perhaps I could find some leads during a 2-month residency there in fall 2019. When I began the interview project, I asked myself, how hard can it be to find someone to talk to? I started with Nancy Beckman, a shakuhachi player in Berkeley, California. She and her partner Tom Bickley introduced me to different shakuhachi-specific notations. They referred me towards Ralph Samuelson, a longtime director of the American Asian Cultural Council. He directed me towards Elizabeth Brown, composer, flute, shakuhachi, and theremin player. She then connected me finally with Kohei Nishikawa, kabuki, buyo, nose, and classical flute player. One would think that after 5 consultants, I'd be able to get some kind of an answer to the question like, are there any scholars interested in or writing about the technologies of notation and representation in Japan? At some point, I realized that this question really meant nothing to my interlocutors. We had been speaking of all these things, but their perspective on notation was just different. Perhaps it was my categories that made no sense. After some time, they referred me to Japanese composer Mamoru Fujieda, who would be interested to talk to me about scores. I await that discussion with eagerness.
Ensemble projects in Montreal, Berlin, Pune, Oslo, Istanbul, Toronto, for example. Ensembles in which each musician in the ensemble comes from a different music tradition, anything from Chinese, Indian, Turkish, Arabian music to techno and free jazz. Our work usually can be characterized as collective improvisation. We start with almost nothing and end with a large repeatable piece. In these ensembles, working with conventional notation would be useless because half the musicians never use notation in their performance practice. Yet we need notations to remember what we once did, like in the Sufi story about the feast. These rehearsal notes that I made are nothing like what we at tenor would often think of as notation. They are neither transportable because they are only intelligible to the members of the ensemble who participated in the process. Nor are they forms of representation because they in no way describe what the audience heard or should hear. Rather, they are indexes for mutual listening and codependent musicking. In most cases, the actual notation, I mean pitches and rhythms and timbres and so on, exists purely as a constellation of embedded memories within the bodies of the various individuals. None of these pieces can be repeated or interpreted in any way, even if even one of the musicians changes or is absent. Only with the right musicians do these notations exist. And then they exist as powerful technologies of collaboration. I have called such technologies Shabda Gaditara, a Sanskrit neologism which says the crossing over of different ways of making sound and music. And in a talk at another symposium in a few days, I will propose a new musicological category of non-transferable people and situation-specific collective scores, to be called Shabdika scores.
South Indian music seemed an easier choice for me. I had studied in Bangalore in 2004, and I knew more about the Carnatic tradition and musicians there, and had been following the social media explosion of my percussion guru, B.C. Manjunath, a Mridangam player and Konakol performer. In my discussions with him, I was interested in Konakol, the percussion language, as a transmission method and scoring method. Konakol has become popular only fairly recently, and Manju explained how, especially during the pandemic, sharing it online has helped spread this unique way of developing rhythmic material to many more performers. The video he makes are aimed not only at Carnatic, but all musicians. Indeed, the most popular video with more than 500,000 views combines Konakol and Carnatic concepts with the Fibonacci series. Many videos spark other video responses by musicians all over the world on other instruments who use these as scores. Let's see if this will play. Anyway, you guys should check it out. This online and many of the online Konakol examples speak to a number of issues that the consultation process brought up for me. First off, I'd been thinking about how orality could be integrated into score research. Hereditary traditions and ancestral knowledge passed on orally create living and evolving scores and structures. Score bearers start out as careful listeners before they become interpreters. And collective creation and knowledge sharing rather than individual authorship is the norm. Second, Manju's use of video and social media was fascinating, a kind of fascinating technology of notation and representation. In those videos where he provides transcription into Western conventional notation, it is even a technology of translation. How might these uses of technology, not for the inscription, engraving, or notation of the score, but as an auxiliary to orality, create opportunities for dissemination and transmission, a novel kind of secondary orality?
In Pune, in the Indian city of Pune, I have an ensemble and I work with 5 to 7 musicians from different branches of Hindustani music. Our ensemble calls itself SangeetTEX, Ensemble for the Exploration of Music. That already is unusual for classic. In this music, the notion of the notation is not absent, but it is not something you use in concert. We could see the notations in the Svarlipi and these formats. They're never used in performance. They're only used for practicing. So, it does not guide your music making in any way. Notations are only used for other contexts. In one instance, though, I wanted to see whether it's possible to introduce a digital score as a performance guide. My piece, Muturanga, Colors of Memory, I confronted the musicians with randomly generated pitch sequences. So these are pitch sequences, I didn't have the time to put in an Indian font, so I used Western lettering. These things move all the time. They move around the screen. They change colors, and so each musician has their color. And when the lettering gets bigger, they're more important in the texture of the music, and then they fade back into a little subservient role and disappear. And so these, that's what they get. And so their task in reading this is very multi-layered. So they need first to decipher and contextualize these random sequences. These are randomly generated pitch sequences, and they needed to understand them as a possible part of some rag. So what part of a rag is this? Part of which rag could this melody be? from a piece of ligeti or something else. Then each musician had to improvise in that rag that they had discovered, and all this while other musicians were busy interpreting their music in another rag. So it's a polyragal way of playing, which is also very new for Indian musicians. And it's almost impossible to do this within a Western paradigm, obviously, because you need all this embodied knowledge of Indian musicians in order to even read what's going on there. Within the digital score project of Craig Rear, we're currently preparing a comparative study of several performance-related Indian scoring systems. So not the one that we saw today, but there are others, newer ones. And the very different roles of the performers as scores that they play in such network constellations.
Of particular interest to me were my discussions with Indigenous musicians, Raven Chacon, Suzanne Kite, and Dylan Robinson. In Canada and elsewhere, the creative music and sound community was rocked by the publication in 2020 of Dylan Robinson's Hungry Listening, Resonant Theory for Indigenous Sound Studies. This book introduced many of us to key concepts like listening, witnessing plus, Indigenous logics as structures rather than Robinson thus asks for a new way to think about musicking, especially his term for Western music consumption as hungry listening. Never satisfied and always in need of new ideas and concepts is a potent challenge to our habits. With Raven Chacon, who has just yesterday won the Pulitzer Prize for Music in the United States, we discussed the unwritten components of his American Ledger series, which to my mind lacked very crucial information. He seemed never directly to address my questions about the scores or the question of score in general. Only long after our conversations, while transcribing them, did I realize that he had indeed answered my questions, not directly, but in the way in which he spoke about them. I realized that I, as a musician trained in the interpretation of written scores, with specialized training in historical performance practice of medieval and Renaissance scores, where we must elucidate and uncover the unwritten, that I may have been entirely missing the point. There probably wasn't anything missing from Raven's scores, despite the fact that they did not contain, in their written form, all the context that he had shared with me in conversation. Information that to me seemed intrinsic to an understanding and performance of the work. Raven Chacon's scores do not require such explanations. They work well within a cultural process. As structures rather than content, community-specific frameworks, and context-specific practice. Furthermore, Raven had transmitted all of this to me not through discourse, but through storytelling, the story of his relationships to the people, alive and beyond, to which the works refer, the story of the communities about which and for whom these works were written, and the narratives that the works themselves tell.
Often when we speak of a score, we think of the material object, whose very materiality gives it greater meaning and creative substance, and I include a computer display in this. Or text editions with facsimile for authenticity, acceptable PDFs for composition competitions, or cuneiform tablets purporting to bring us the first songs. There seems to be a bias to considering that the materiality of these inscription devices make the score a piece, a work, or a song. Considering, however, that music and sonic art are in fact the domain of pressure waves within the air, can this material object really stand in for a performance? If we consider childhood development, the history of music and sound making predates language, and certainly any mark making. In many non-European cultures, the material objects we call score has mostly only acted as one of several auxiliaries to music making, which includes many other ephemeral oral not something that can or even may be written down. In some cultures, singing a song out of context can be subject to a taboo because it may anger or hurt an ancestor. It may require a specific context to be sounded. I'm currently working with a group of indigenous musicians who cannot teach their children their songs because that would break a taboo. Singing a song out of context would not be allowed.
Biases are often embedded into language. In English, perhaps more often outside the tenor community, the words notation and score are often used interchangeably. This shows how much we consider that mark making and writing are indispensable to the notion of scoring. We speak of literacy in music, reading music as the best way to decipher scores. Perhaps the scores even comply. In German and in French, there is only one word, partiture or partition, referring to a collection of the parts of a whole. In both languages, a single line cannot correctly be referred to as a score, and this would rule out partitions for many of the world's monodic musics. The etymology and shared meaning in modern usage also speak to divisions and sharing of land, labor, territory. In the parallel rise and perfections of scores, partition, on the one hand, and Fordist assembly lines with their and looking at the world in other humans. Is Charlie Chaplin's film Modern Times also a critique of the musical score? Poking at the word score etymologically and in its other modern usages, we come back to notions of making an incision and the keeping of tallies by cuts or incisions in more recent parlance. In my own mother tongue, Czech, as in German, there is partitura and noty, which connects it to note. How many of us imagine a pitch with a duration when we think note in a musical context? Is this truly the best combination that is notatable in music? Sandeep has introduced the context of a perspective of notation to describe such methodological biases.
Any experience and making of music consists of a multitude of different factors. When we notate, we invariably choose which of these factors we notate. But this choice must be seen at what it is, willful and contingent on one's cultural and traditional context. We could have chosen to notate the timbres of the movements of the activating body. We could have chosen to notate the color of the musician's dress or the audience's clothes. We could have chosen to notate the smell and the lighting of the room. And indeed, composers and traditions have again and again chosen to do precisely this. That they open up the field of inquiry to include precisely such factors too. Anything that can help recreate a complex, interconnected musical feast. Why then would our 21st century technologies of scores want to limit their conceptual focus overwhelmingly on the same parameters as those that were randomly chosen by some French and Swiss monks in the 9th to 11th century?
Vanessa Machado de Oliveira writes, within modernity coloniality, being is defined by reason, and it is certainty of knowing through description prescription that anchors the security of being. To what extent do Eurocentric definitions of notation and representation depend on our drive for prescription description as based in modernity and coloniality? Critiques of this often come from the global South and from indigenous peoples. They point to the imposed sense of separation between ourselves and the dynamic living land metabolism that is the planet and beyond, as well as the theological separation between creature and creator. This imposed sense of separation or separability is based on human exceptionalism. Our scores, our attempt to control something that is essentially cannot really be dominated.
Even if we only consider the ecology of human musicking itself, there still can be associated with musicking. In learning and training and in rehearsing, recording, performing, digitalizing, and so on, archiving music. This can be seen as positive, of course. Notation as the Swiss Army knife and the great unifier of the Eurological music narrative. But keeping the critique of the indigenous epistemologies in mind, one can also see the pervasiveness of mark-making notation in every aspect of a practice as a dangerous viral infestation. Why should mark-making be part of everything we do in music? Not at least because it seems to normalize this practice to the extent that any musicking unwilling to use notation in the same pervasive manner is perceived as underdeveloped or maybe othered, or as the music of somebody who is more ignorant. So I'm just, stop. You can just see here that this is, we see notation is the gray big bubble there, and it is really overlapping with everything we do in Eurological music. Whereas if you see Indian, just as one example, notation is also a gray bubble. It exists, but it has a very different role, and it doesn't even come close to composition, listening, or performance. It doesn't play any role there. So these different social roles, such diagrams could be drawn for almost every musical practice. They would look different. And we need to know these differences in order to understand in which context we can use notation.
The most promising aspect of new notation technologies can be a new perspective on improvisation. For a long time in the so-called West, improvisation was both racialized and correlated with typical racist attributes. It was seen as sonically dirtier, sexually more immoral, socially more irresponsible than notated music. New scoring concepts and technologies since the 1950s had urged composers to relinquish the level of direct control, which we can see in mid-20th century scores such as Stockhausen's Gruppen, by replacing it with indirect or meta-control. This meta-control has subsumed improvisation into the sphere of the notatable. Of gentrified idiomatic improvisation. Digital scores for improvising musicians thus are a kind of gentrification, accepting this previously racialized and socially outcast musical praxis into the bourgeois concert hall. Here we again clearly see the role of notation as one of the many demarcations by which the musicings of colonial subjects and racialized people are kept apart from the safe and exclusive environment of Eurological musicking.
When years ago I reintroduced the term comprovisation, contrary to what was suggested yesterday, it's not my term, I just started to use it at some point in a specific way. When I reintroduced the term comprovisation into the aesthetic discourse, I needed to define the notion of what a score is. Any performance or enaction of musicking is a completely unique event. No two performances can completely be alike. Even if, like the feast from the Sufi story, their only difference may be that they happen at two different moments in time. Some of a performance or enaction's aspects are always predetermined. Sometimes the pitches and rhythms, but sometimes the stylistic context, the people performing, the ritual of the concert presentation, the timbres, the venues, and so on. Other elements are also contingent in the moment. Sometimes the pitches and rhythms, sometimes also the stylistic context, the people contingent too. So the score, as I defined it then, is any device or any custom, any constellation and prescription that declares which components of this complex event, of this unique performance, are those that should be carried over to the next instantiation of this event. A score is therefore anything that those responsible for the artistic integrity or the commercial or community relevance of an event, could be the composer, the master of ceremonies, the community of followers, the keepers of tradition, the sponsor, what those people think they want to see present in the next instantiation of this same thing that they may call a piece.
Scores in our culture are tied to authorship as a means of monetizing cultural capital. Perhaps in alternative definitions of score, we might be inspired by the common linguistic root of economy and ecology. The Greek word oikos, which means the family, household, environment. What might happen if we focus more on the collectivity and ecology of creation, beyond individuals, specific temporalities, or even the human species?
André Leroy-Gourand, anthropologist, describes technology as an interposed membrane between our exterior milieu, the geography, this membrane, technology, is often seen as kind of passive or neutral. But what if we conceive of it as an active agent in our scoring of the world? Software applications and artificial intelligence might thus create new exterior milieus for humans through scores. This is something that I think many people are thinking about. But could they not also feed on the elements of human interior milieus, such as societies, communities, and techniques like storytelling, or the various interpretations of what a sensory input means to people?
How do we know we have activated spaces and relationships that resonate and made mutually stimulating connections? How can we break out of exclusively prescriptively oriented, executant-focused scores and involve the whole oikos and are situated and invested in space, place, time, and community?
We know that humans are not the only sound-making entities of the world. And we are not only the only listeners either. Since the Western demystification of the world, various artistic and intellectual movements have reminded us that our connection to this world cannot only be one of dominance, that it is also one of immersion and codependence. How are we ourselves subject to scores written into our genes? And how do these scores and the listening and sound making they produce connect us to the world around us? A friend of mine, Tibetan shaman. When he does not conduct a new piece by a neurological composer, he sings to the trees in his forest and to plants in his garden. He insists that such singing obeys very different timescales, obviously, and produces listening reactions that can only be measured in seasons and years. Can we not only exploit natural sounds? You know, that's what people do very often, exploit natural sounds for their electroacoustic or acousmatic pieces, but also be and sound with and imagine our scores to enhance our co-presence with other entities on this planet.
Will it be possible to move towards a new balance of voices in our tenor communications and conferences? The biases that we cling to are deep and pervasive. They extend beyond our lifetimes. So unlearning is a slow process. It seems important to us to seek out and find interlocutors and build relationships in areas that so far have not been represented at tenor. Wonderful new taxonomies of practice are empowering expanded score activity, as witnessed by Craig Veer's digital score. Perhaps similar new definitions, explanations through other languages, lists expanding on oral or transgenerational transmission could likewise spark
We must allow other kinds of gestures to emerge and resonate in this still emergent community around the technologies of notation. Commitments and radical change are necessary and can catalyze incredible shifts. And there are countless examples around us of small changes at one point that then propagate fractally throughout the system. What does this require? Firstly, of course, financial support for those who have been marginalized or underrepresented, perhaps beyond what might seem reasonable to us from our place of privilege.
Secondly, perhaps we have to become much better listeners too, so as to avoid filling the space with our noises and voices, turning it into an echo chamber. Thirdly, Our models of inquiry and desire for inclusion may not be welcome or appropriate everywhere. For example, Robinson's book Hungry Listening emphasizes how important it may be to refuse the kind of dialogue that confirms colonialist ways of seeing the world. Instead, he proposes forums that allow both effective experience, whether repulsion or wonder, to emerge and provide sovereign space for Indigenous people to continue to define and enact the work of resurgence. Not only Indigenous people need such forums for their unique forms of knowledge, we as a community and conference deprive ourselves of many important and enlightening aspects of our field of notation at such scientific conferences.
Music is writing into air, or writing on the wind. The fight against ephemerality was for a long time the motivation for scores. But most non-written scores, both those before and after the written score, are themselves ephemeral. In oral transmission, a rule to be memorized dies with the memorizer. And in digital scores, a software score becomes illegible within the space of a few years, unless it finds gardeners who care for its constant needs for adaptation and change.
If tenor wants to become more sustainable, we must talk about gardening scores, about creating conditions for their growth and persistence. Music always is a fruit that can only be picked from well-tended scores. In many ways, any expanded understanding of the score, whether in the direction of a secondary orality or in the direction of algorithmic situativeness, makes the centuries of written scores seem like a glorious misunderstanding, one that mistook descriptions and abstractions to be more important than the thing they described. One cannot eat the drawing of a fruit. Like its genetic code, the digital score, it always needs a living environment, a community around it, in order to grow at all.
We need to move towards a sustainable ecology. Or with their software and hardware platforms. All these examples from beyond the kingdom of the written, visually dominant score objects show how such ecologies might emerge if we expand our notion of what a score might be. Thank you.
Thank you very much, Terri and Sandeep. Just a point, after the questions, we have just a little talk about Tenor 2023, because Tony DeSantis can't be there at the end of the conference, so he must do this talk just now. But have you some questions for Terri and Sandeep?
As a former biologist, I was, of course, very attracted and enticed by the biological metaphors, ecological/biological metaphors that were presented in your presentation. Thank you very much. It was very thought-provoking indeed. I was just wondering, since we're just experiencing a process. I mean, your ideas, Terri, are novel ideas that maybe developed over the past 20 years, and we can, and have acquired grand scheme of things. We can apply some of the ideas that you find in writings by Richard Dawkins, who has looked at genetic code and found a representation of that in cultural processes. And he was actually the person who coined the term meme, but unfortunately it has been misappropriated by the internet culture. And so it's like, when I shy away from using the term meme, because people understand, interpret this as something different. But let's go back to Dawkins and the kind of evolution that he describes, and when we're going back to genetics, you have like a mutation and selection. So you are putting an idea, you're putting forth an idea, you're creating some sort of an echo chamber, of course, for new ideas, and these are bouncing back, you know, in this particular case from, you know, from the brains of the tenor community, and so the idea is, how is this? Where do you see this, or how do you see this developing in the future? Isn't it also a question of, you know, power structures that will either prevent these new ideas to survive, or they will allow these ideas to flourish, and all the other you know, forces in this whole environment that either are you know, enhance your ideas and these yeah, perspectives that you put forth. Sorry if that doesn't make a lot of sense, but these are ideas that just came to my mind.
Yeah, I'm struggling to sense the focus of the question, but to stay with the sort of evolutionary metaphor and how to think, whether things survive and the right things survive, if that's maybe what I sense from your question. There are things that are missing from our discourse here, and we could talk about whether it's because you know, they haven't survived well enough to be really discussed. But I keep thinking back, in my case, coming from being a settler in North America, to indigenous culture there, which went through a period of cultural genocide, and it's really quite amazing that it survives. And if we think about these you know, Western evolutionary terms, we could think, oh, well, it's so small, it's unimportant. And yet it has managed to survive despite incredible oppression. And now it's, and through storytelling, through these completely other forms, it's about enabling, about saying, okay, maybe it's not just survival of the fittest. Maybe we should just start listening to these voices, because there's something there to explore, and otherwise we're just reproducing the same things. And you know, in a place like North America, it doesn't seem ethical to be reproducing European culture in a space where there is already a culture. So it's also these things. We didn't get into a lot of ethical talk, but yeah.
I just want to add something. So we are at the margins of the music world, right? So this is not a 10,000 people auditorium. It's not a stadium where new musical ideas are proposed. We are operating in a very marginal community within the musical scene of the world. And there has been a tendency in new music and in music technology to isolate oneself even more. And I think that's one of the root causes of my intention in this talk, is to say that's really not healthy. It's really not healthy to isolate yourself from what we call the mainstream, or, you know, common practice, in a way that doesn't include all the concepts and the ideas that from other musical practices that exist. Improving Western neurological new music traditions, we're really propping ourselves to one little branch of a very big tree. This is not the current discourse of how this scene thinks about itself, but grandiosity has always been part of the new music scene. So it's not always founded in fact, this grandiosity of self-image. So I'm just saying, if we want to continue the biological metaphor, we're on a very strange mutation
that we are adding on to very strange mutations. If we only look at that, we're missing a huge chance that digitalization and other technologies offer us to get out of that corner and to actually connect to actually things that exist elsewhere in the world. The example of India is not randomly chosen. It's one of these music traditions that has consistently resisted any score representation, because the way Western scores were conceived did not at all, you could hear in the other talk too, it did not at all fit the way that Indian musicians think about what they do. So digital technology offers this chance that they can invent a way of representing what they do in another format. For that, there needs to be connections being made. We need to offer the tools that we have developed in an intelligible way, in a culturally sensitive way, and in an because Western notation is just one possible way of engaging with it, and I don't know if it's really helpful for Indian musicians to want to be understood by somebody in the Czech Republic who only reads Western notation. Maybe it's much important to be understood by 100 million Indians who read that, who can read that. So that's just one thought that I had in this context.
Yeah, well, responding quickly to Terri, you used the term Western evolutionary, so what would you say, evolutionary terms, Western evolutionary terms, yeah. As if, and that's something that I'm starting to, trying to wrap my head around, is as if there was like something that works outside that, the notion of Western evolutionary terms. I personally believe, as a formerly trained scientist, that we need to develop terms, evolutionary terms, that are universal and that work for any kind of culture. Like we have been able to describe genetic evolution for any kind of organism, because the mechanisms are, pretty well defined in genetics. Right, so we need to kind of be able to get to that point also when we look at culture, and I see cultures through digital media is actually going to open this door, because we see kind of rhizomatic, connections being made between cultures through digitization. And I'm just embarking on a project in Africa with Kenya, and I'm working with the British to send me some videos from a village in somewhere in Kenya. And what I could see with on these videos, that people had their cell phones placed right in front of them, just like we do. I mean, just by using digital technology, we have already kind of created a sense of community which was unheard of just a few years ago. And I think these devices are real enablers.
Yeah, it's not so different from what we were saying. It's just that, as Bruno Altro says, there's always this talk about post-modernity, but we have not even been modern yet, because the modern project is to include most people, and it has not happened yet. So digital technology is one of the things that is making that even more possible, and we should really embrace that, I think. Kat.
Thanks, Sandeep and Terri, on that presentation. Really great and thought-provoking and important in this context. I have a question about context. So music develops in all cultures, right? It's not static, it develops. So if in the ideal situation that it's more open and inclusive, how do we avoid the mistakes of the past, which is pretending to understand depth of culture in places which none of us have any cultural hook or relationship, and oversimplifying or expecting an oversimplification as you say, in order to fit into our systems, because these are our systems. We can change them, but they'll always be coming from us. We're led by us. And I feel that a lot of minorities believe in self-autonomy and nothing with us, nothing about us without us. Just wondering if you could say something about that.
Yeah, I think that's super important, especially when talking about this, conference contexts. I think this is a format which works for our Western way of thinking, and a lot of cultures are just not. They don't want to discuss things in 20 minutes without a talking circle, without, like you say, a sovereignty over the space. And this is something that, if we want to dialogue with these other cultures, I think that we're going to have to think about radical changes to the ways that we it's already hard for us to force ourselves into this, the 20-minute format. So to really think, well, maybe we just need to change this. And instead of including one racialized person in a concert, to ask that person to curate the whole concert and to define what that concert will be, or if it'll even be a concert. So it's also about allowing the systems to loosen and into just be replaced by something completely different without wanting to always put it into our framework. So how much are we actually willing to let go of in these processes, especially in terms of leadership and decision-making?
Another aspect of this is what I call creative misunderstanding. There's a type of indigenous Indian music where people use radio. Radio was one of the first technologies introduced to indigenous peoples, worldwide, very long ago. And like Cage, they used radio in a very different way from what it was intended. They use it as a percussion machine. So created their rhythm accompaniment with radio, which in their region at the time didn't have any reception. It was just a machine and there was no radio station. So all it produced was noise, and they used this to create percussion. Some intent, it's misused by somebody else with their own sovereignty of what they want to do with it. And that's part of, giving over control in certain situations and giving over agency and even the control about how this should be read and how this should be understood to another perspective would be of great help for us too, because we then finally get to experience the other perspective, which we normally deprive ourselves of.
Yes. Yeah, thank you. It's very fascinating talk, and I think super relevant. I want to be a little bit like a devil's advocate, and I wonder whether the very notion that we should find a project that will include everything is maybe that's a little bit a problem. Maybe that's a little bit pretentious, and maybe it's okay that there are things that are specific to Western or Eurological culture, things that are specific, or frameworks or ways of thinking that are specific to other cultures. And we can go to their frameworks and learn from them and then implement things within our ways of thinking, but it doesn't have to be like a single thing, single tenor network that encompasses all the ways to represent.
When the Tenor Network was started, it had this vision of, filling up that map. So, in a way, a lot of these thoughts have come from how to do that, and whether that's something worth striving for is debatable. It could be technologies of notation and representation in neurological music. That's also fine. But maybe there's a lot of people who might not want to be involved in that community. And there are things which are also beyond culture that are problematic. For example, the gender representation at these conferences. So then you have to ask, well, do you want to continue with that kind of exclusion? Is that something that we want to be blind to? And certainly for those of us that are women or non-binary people, maybe we don't necessarily want to be involved with such exclusionary spaces. And I can imagine that it would be the same for racialized people. And then, I guess, you have to decide whether you want to be included in a group like that. That would be my answer to the devil's advocate.
Also, one short remark on the universal. Mostly calls for universalism have been in the nature of we should all speak one language and it should be English, and if you say the same thing, we should all speak one language, yes, but it should be Swahili, most people would not agree with this universalism. And there's a reason for that Dipesh Chakraborty has named in his book Provincializing Europe, which is that universalism is always an expression of power structures, and that the only way to get into something exclusive would be to provincialize what we're doing. So say, continue what you're doing, continue to love Brahms, for example, or love Stockhausen, no problem with that. Just say that it's not universal in its appeal. It's not. And don't assume that this is the way forward into the future. It may be a dead end too. There are, or it may be some especially interesting mutation that then develops into something completely different in future Ugandan music. Luc Ferrari has had a huge impact on techno. Who would have thought? And that kind of, these kind of correspondences that grow could be interesting, but it's not really, at least Chakraborty thinks it's not feasible to postulate a universal, and that's my answer to Georg, to a universal cultural code. It's used, and that already presupposes hegemonial power. And we have this, of course, we have these hegemonial powers. And one way of not conceding to hegemonies of that kind is to propose other models of how to interact with each other. In the long term, it's a slow process of unlearning. And it starts with talks like these, I think.
Thank you so much, Terri and Sandeep. Terri, there.
Hi. My name is Anthony Paul-Doritis. I'm going to be working with 2 other institutions in Boston next year to have tenor in Boston. So I'd like to take a few moments to tell you a little bit about that. I will be brief, I promise. It would be brief. So what I decided to do is to, without permission, use, if you know the rock band Boston, I took their logo and I decided to appropriate it, which of course goes with the Eurological approach of appropriating things when they shouldn't be doing so. 23 Boston, here's a beautiful pic of Boston welcoming you. The proposed dates for Tenor 2023, Tenor 2023, May 15, May 17. Boston is a 3-way partnership of the music department at Northeastern University, where I am, the Longy School of Music at Bard College, and the New England Conservatory of Music. Here's a map of Boston, just to quickly give a sense. This is about 3 miles between the Longines School of Music, Northeastern University, and New England Conservatory, which is about 15 inches away from one another, these two institutions. And it's quite a direct access to the Longines School of Music, which is sitting side by side with Harvard University. And there are a few other institutions in between, like MIT. The Berklee College of Music is here. Over here is the Boston Symphony. Over here is the Boston Conservatory, all within a square kilometer of Northeastern University and New England Conservatory. So I will also be in touch with our neighboring institutions as well to see if they would like to participate. Here's a map of Northeastern real quick. You can see here's Northeastern University. There's a New England Conservatory very close by. Who are we? So I'm the conference chair, Anthony Polderidis at Northeastern University. I'm the co-founder of the Music Technology program at Northeastern. The scientific program chair will be my colleague Victor Zappi. The paper chair will be Jeremy Van Buskirk, who's the associate dean. Who is director of the Robert Seeley Electronic Music Studio at New England Conservatory. Here's a beautiful pic of Northeastern, yet another. Northeastern was founded in 1898. We have a lot of students. We were in the top 50. We've been striving. When I got there in 1998, we were 169th. So we are making great headway. I won't take all of the credit. But we're perhaps most known for Sean Fanning discovering and creating Napster on our campus. I bet you didn't know that. Okay. All right, so here we have Ryder Hall, where the music department is at Northeastern University. And our music technology program increasingly just is focused on combined majors that brings together computer science and music technology, electrical engineering, physics, game design, and most recently, music perception cognition. Northeastern also, we had the first BOYLE and Pierce conference. Thanks to Garrett Hoydu, we collaborated on that, which was a huge success for us. We also worked closely with Hans Tutzku for the Sound in Space Festival in 2011. So we're open and excited to collaborate with everybody. That's me. You don't need to know too much about me other than I really like this headshot. I was a student of David Wessel at the University of California, Berkeley, where Garrett Hoydu and I, we met as graduate students, and he TA'd the class my first class I took on Max. Garrett Hoydu introduced Max. So thank you, Garrett. Right? After that, I was David Wessel's assistant for several years. SB at the Central Conservatory of Music. With Chinese traditional instruments. And so I kind of understand the idea of wanting to study and also learn from other cultures. This is my colleague, Victor Zappi. Right ahead, let me just say that well, Victor Zappi just came in. We got him from Italy a couple of years ago. He's going to be our science chair. Just briefly, he is focusing on creating new instruments, and he's done a lot of work at IRCOM. We're very excited to have him. That's Victor doing his thing. These are some of my colleagues. I won't say too much about them, other than really our focus is in computation, digital audio, music perception, and cognition. My colleague Psyche Mooney, who was also an assistant to David Russell for many years, just won in the United States what's called the National Science Foundation grant for a career award. And my colleague, Dr. Ronald Bruce Smith, Canadian, he is the current director of the Music Technology Program, composer. That's our Fenway Center. We will have some events at Northeastern in terms of performances. The two institutions we work closely with, the New England Conservatory of Music. This is my colleague, John Malia, who will be the Sonic Works chair. Some information about him, in particular being composer residence at the Institute of Music Electroacoustique in Bourges. That is the brand new building at the New England Conservatory. We're very excited about, and also houses this wonderful black box theater, which they are making available for our event. Jeremy Van Buskirk. But he will be the paper chair in collaboration with my colleague Victor Zappi, and he is currently the associate dean at the Lange School of Music for 5 years. So they were very excited about the traditional connection to French culture. There's a picture of the Lange School of Music, and this is their wonderful Pickman Performance Hall, where they will also host a day of performances and events. So what's next? A specific orientation toward the conference is still forming. That was extremely kind of inspired by the most recent keynote talk. To that point of keynote speakers, it is not lost on me that we have 4 white men currently overseeing this event, so we are guaranteeing that our keynote speakers will not be white men. Right? So that is a very basis. I'm planning on saying that. We have some women in mind, and certainly there's others, but let me just get that out there. We'll be doing as expected, but most importantly, we're going to work with the Tender Steering Committee. We'll do all the associate requirements of developing the website, doing the call for papers, workshops, demos in a timely manner, and most of all, they're working with you, the Tender community. We want to hear from you. Please do reach out with your ideas, suggestions, and desires. This is my contact information. Please take a moment to take a picture or write it down and let me know your thoughts. Welcome to Boston.
Thank you, Tony. Let's go to lunch. It's late. It's late. Just here. If you haven't tickets, I can bring you tickets.
This is just like that's right, but